Hello there, and welcome to Just About Earth, where curiosity settles in quietly, and the world grows a little softer around the edges as we explore questions that sit just beyond the edge of ordinary thought. Tonight, we're wandering into a landscape shaped by ice and silence, a place where the cold carried secrets long before any living person wondered what might be hiding beneath it. The idea we're easing into is simple at first glance, but the more time you sit with it, the more it opens. What if our planet once held a civilization that thrived before the last great ice sheets arrived? A civilization so thoroughly erased by advancing glaciers, rising seas and shifting continents that not a single whisper of it survived in the places we usually look. When the world froze and the great ice fields pushed across the land, whole regions were transformed into deserts of snow, leaving nothing behind but hints buried where no sunlight could reach. If there had been people in those places, people with stories, tools, settlements, or something far more unexpected, how would we ever know? That question, as cold and quiet as the Ice Age itself, guides us this evening. Before we settle too deeply into the layers of this possibility, I'd love to know where you're listening from right now. Maybe you're somewhere warm, curled under a blanket with the lights low, or maybe you're somewhere cold, where the air outside feels a little like the distant echoes of glaciers that once shaped your landscape. And what time is it for you at this moment? It's always interesting how different hours fold together here, people stretched across night and day meeting in the same quiet space. If you find this kind of slow, thoughtful exploration comforting, or it helps you drift gently toward rest, I'd be grateful if you gave the video a like or subscribed. It helps bring more curious minds into this calm corner, where the questions are steady, the pace is gentle, and the stories unfold one breath at a time. Moving forward into this idea takes a steady approach, because the suggestion alone opens so many paths. The Ice Age is usually spoken of as a time when humans were scattered across the world in small groups, following herds, making tools from stone, carving out ways to survive in harsh conditions. That's the version we grow up hearing about in school. But imagine taking a step back and considering how much the ice actually changed the shape of Earth. Entire continents had their coastlines moved, mountain ranges were carved, valleys deepened, rivers redirected, habitats erased, and enormous regions simply vanished under hundreds of meters of ice. The world we see today is not the world that existed before the glaciers arrived. Much of that older world is gone in a literal physical way, not just forgotten but crushed, scraped, drowned and buried. Anything that might have been built there, whether it was simple or advanced, would have been hit by forces powerful enough to erase nearly all traces of it. Thinking about that makes the question feel less like a fantasy, and more like something worth considering with an open, steady mind. Something interesting happens when you acknowledge that most of humanity's ancient coastlines now lie underwater. During the height of the last ice age, sea levels were dramatically lower than they are now. Great shelves of land extended far beyond today's beaches, forming regions where people could have lived for thousands of years. As the ice melted, all of those areas disappeared beneath rising water. If any early civilization, even a small one, settled along those now lost coasts, their remains would be far below the surface, inaccessible without technology we've only recently developed and still rarely use for this kind of search. It raises the question of how much human history lies underwater, untouched, unseen, and effectively unrecorded. We're used to imagining the ancient world as something we've fully mapped, from ruins on mountaintops to artifacts hidden beneath jungles. But the truth is that most archaeological exploration happens only on dry land, and even then in small patches of it. Vast regions of the seafloor, possibly containing traces of Ice Age communities, or something entirely unexpected, remain unexplored. Thinking about that offers a soft but steady sense of mystery. People often assume that if a civilization had existed before the last glacial maximum, we would see clear evidence of it today. But the Ice Age wasn't gentle. It was an era defined by pressure, freezing winds, violent climate shifts, expanding ice sheets that ground the earth beneath them like a giant slow-moving millstone. Imagine a settlement sitting in the path of a glacier. As the ice advanced, everything in its way would be pushed, broken and buried. Structures would collapse, materials would be scattered, organic remains would be crushed or decomposed. Even stone foundations could be scraped away by layers of ice as thick as skyscrapers. Over thousands of years, as the glaciers continued their march, any trace of what might have been there could disappear completely. Later, as the ice retreated, meltwater would flood the land, carving out new valleys and washing away the few remnants that might have survived the crushing weight. The idea of total erasure suddenly feels plausible, not as a speculative story, but as something the planet has done many times. You're probably picturing wide open plains covered in blue-white ice, stretching so far in every direction that the horizon dissolves into a gentle haze. But during the last ice age, the world wasn't uniformly frozen. Many regions stayed surprisingly mild, fertile and open. Some areas had climates similar to modern northern Europe, others were lush with game and vegetation. It's entirely possible that groups of people lived in locations we now think of as inhospitable, simply because those places looked very different more than 20,000 years ago. The landscapes were shifting constantly, with coastlines expanding or shrinking depending on how much water was trapped in ice. Rivers wandered, wetlands formed, and entire ecosystems evolved in synchronicity with the cooling and warming cycles. Humanity, being adaptable and inventive, would have followed those changes. It makes sense that if people had the capacity to develop something more complex than simple hunter-gatherer life, they might have done so in these forgotten pockets of land. Another thought worth holding is that technological complexity doesn't always leave behind dramatic or indestructible traces. If a civilization developed with materials like wood, plant fibers, lightweight structures, or tools made from composites that degrade over time, very little would survive thousands of years of climate upheaval. Even today, if we abandoned a modern wooden town in a harsh region, within 1,000 years almost nothing recognizable would remain. Extend that time span to 20,000 years, add glacial erosion, rising seas, and constant seasonal cycles, and the chance of finding even a fragment becomes incredibly small. This doesn't require imagining advanced technology or mythical achievements. It simply acknowledges that human cultures might have risen to levels of organisation or craftsmanship that didn't rely on stone monuments or metalworking, and thus left almost nothing that could withstand millennia of environmental stress. You may be noticing how these layers stack together: a shifting global climate, rising and falling seas, expanding ice sheets, lost coastlines, fragile materials, erosion, flooding, tectonic activity. All of these processes suggest that Earth is very good at wiping its own slate clean. We often forget that the planet has reset itself many times. Forests have appeared and vanished. Grasslands have swept across continents and then disappeared. Lakes have dried and reformed. Even mountain ranges have been rebuilt. Against forces like these, human structures or artifacts would be incredibly vulnerable unless they were built intentionally to last, and even then the odds are not in their favour. When you think about this, the possibility of a forgotten civilization shifts from imaginative speculation to something that sits comfortably within the range of natural history. It's also helpful to remember how little of Earth's surface has been carefully examined for ancient human activity. Even well-known archaeological regions have enormous gaps. Most of the world's deserts have barely been surveyed. Many forested regions hide layers of soil so thick that entire settlements could vanish beneath root systems and fallen leaves. The ocean floor, which once held many habitable regions during lower sea levels, remains largely unstudied outside of narrow commercial or scientific interests. When you consider all of this at once, a quiet possibility emerges. If there were people building communities before the Ice Age reached its peak, and if they lived in regions now underwater, or beneath areas once crushed by ice, We might simply not have looked in the right places yet. Something gentle settles in when you consider how memory operates on a planetary scale. The Earth doesn't preserve everything equally. Volcanic ash can protect a city for centuries. Dry caves can keep bones safe for tens of thousands of years, but ice, water and wind can erase entire landscapes until nothing remains but bedrock shaped by forces far stronger than anything humans can build. Thinking about this doesn't diminish the incredible achievements of ancient cultures we do know about. Instead, it invites the possibility that similar achievements could have existed in places we haven't explored, long before the civilizations we're familiar with appeared. This is not about rewriting human history or imagining fantastical lost empires. It's about acknowledging that the world has many layers and that we, as a species, have lived on this planet for far longer than our earliest confirmed settlements suggest. You may also find yourself wondering why this topic feels so intriguing even in the quiet of evening. Perhaps it's because imagining what once existed invites a sense of connection to something much larger than our usual daily concerns. The idea that people, possibly much like us, might have lived through migrations, challenges, discoveries and innovations in worlds now unrecognizable creates a subtle feeling of continuity. We often think of ourselves as living in the most developed moment of human history, but that perspective narrows the possibilities of what earlier humans might have achieved. Exploring this idea slowly, step by step, brings a kind of calm, not because the question is simple, but because the world becomes larger and more intricate as we consider it. Another reason this topic works well in a quiet setting is that it encourages a different way of thinking about time. Rather than imagining history as a straight line stretching backward, this approach recognizes it as something shaped by natural cycles, environmental transformations, and periods where whole chapters of the world's story were rewritten by ice and water. If we accept that many landscapes were remade so thoroughly that nothing remained from their earlier states, it becomes easier to think about how human presence in those regions might also have been erased. A glacier is not a historian. It doesn't preserve, it transforms, and in doing so it may have removed not only physical structures, but also the evidence that would allow us to understand who lived there, how they lived, and what they created. There's a kind of gentle patience required when stepping into this idea. It doesn't rush toward conclusions or arguments. It simply invites you to look at the world as something alive and ever-changing, where entire eras have come and gone, leaving us with only fragments. Those fragments tell part of the story, but never the whole. The rest is buried deep, crushed under ice, washed into the sea, or scattered across landscapes we haven't yet examined. People sometimes imagine lost civilizations as grand or advanced, but they don't need to be either to have existed. They could have been small, peaceful, sustainable, or organized in ways that didn't leave monumental traces. They might have lived along coastlines that no longer exist or valleys long since erased. Their knowledge might have been passed orally, carried by generations that were later separated by the harshness of climate change, leaving no written record behind. All of this sits comfortably within what we know about human adaptability. It feels slow, steady, and grounded in the way Earth works. Human history, as it is taught today, begins with what we can find, not with everything that might have happened. When you think about it from that angle, the idea of a civilization wiped clean by the Ice Age doesn't seem improbable. It simply seems like something we haven't discovered yet. Settling into this idea means stepping slowly into a world that looked nothing like the one we know today. Very little about the Ice Age resembled the familiar forms of continents, coastlines, or climates we rely on now. As glaciers grew and shrank over tens of thousands of years, entire regions shifted beneath them, reshaping the Earth in ways that still influence every landscape we see. Considering what may have been hidden in those transformations requires patience, because the story begins in places we can no longer visit, under conditions that feel distant even though they shape the foundation of our existence. Understanding what might have lived beneath the snowdrifts of memory starts with acknowledging how much the Ice Age erased before anyone could record it. During the height of the last glaciation, the Northern Hemisphere held enormous ice sheets stretching across continents. These ice sheets were not delicate blankets of frost. They were immense, heavy masses reaching heights taller than modern city skylines. Their weight pressed into the crust, and their slow movement carved valleys, redirected rivers, and scraped away anything that stood in their path. Thinking about this helps ground the possibility that if there had been people living in regions now buried by those glaciers, their presence might have been wiped away as completely as footprints on a beach when the tide rises. That's not an exaggeration. It's simply how ice behaves over such long periods. It advances, it grinds, and it remakes whatever lies beneath it. One of the most striking things about the Ice Age is how much land existed that we cannot see today. Lower sea levels exposed vast coastal plains stretching hundreds of kilometres from modern shorelines. These areas would have offered mild climates, diverse resources, and stable environments compared to the colder interiors. It makes sense that early humans would have been drawn to those coastal regions, because coastlines often support abundant food sources, freshwater access, and predictable seasonal patterns. Yet all of that land lies underwater now, submerged when the melting ice sheets poured water back into the oceans at the end of the glacial period. Entire ecosystems were drowned. Forests disappeared under rising seas. Rivers carved out new paths as they adjusted to the changing terrain. Anything built along those ancient coasts would now rest far below the waves, unreachable without specialized exploration. People sometimes picture the Ice Age as a uniform world of unbroken cold, but that image smooths out countless details. Many areas were open grasslands where herds moved across rolling plains. Other areas were pockets of temperate conditions that supported forests, lakes, and rivers. The planet contained a patchwork of environments, and many of them were surprisingly favourable for human life. If a group of people found a stable region where resources were plentiful, they might have stayed long enough to build something more permanent than temporary shelters. They may have developed traditions, tools, or forms of cooperation that allowed them to thrive. None of these possibilities contradict what we know about early humans. Instead, they remind us that our species has always been adaptable and capable of creating complex social structures when given the opportunity. When you imagine people living in those forgotten landscapes, the first instinct is to imagine something simple and basic, but that assumption is shaped more by modern expectations than by evidence. We tend to associate complexity with the presence of durable materials like stone or metal, yet human ingenuity rarely depends exclusively on such resources. People have constructed sophisticated societies using wood, clay, fibres, resin, bone, or combinations of materials that degrade quickly. Over time, these materials break down, especially if exposed to water, shifting soil, or glacial pressure. The majority of human artifacts are fragile unless preserved in very specific conditions. If they were built in environments repeatedly shaped by ice or meltwater, their survival into the present would be extremely unlikely. Looking at erosion alone offers insight into how much can vanish. The movement of meltwater during the retreat of the Ice Age was immense. Glacial lakes burst through natural barriers, sending powerful torrents across entire regions. These floods swept away soil, sand, organic material, and loose stone. They buried some regions under thick layers of sediment and stripped others down to bedrock. It is easy to imagine how remnants of early human settlements could have been carried downstream and scattered in ways that leave no recognizable traces today. A small settlement might disappear entirely beneath layers of silt or be chipped apart by moving ice. Even something built with care could be erased if exposed to destructive forces long enough. Another factor often overlooked is how human populations likely moved during the Ice Age. Many regions experienced climate shift that forced communities to relocate in search of food or more stable conditions. When people move frequently, the structures they build tend to be lightweight. They favour designs that can be assembled quickly or left behind without significant loss. These structures rarely leave clear archaeological signatures. Even today, nomadic communities leave behind very little permanent trace compared to agricultural societies. If Ice Age people followed herds or shifting vegetation patterns, their camps may have disappeared long before the glaciers advanced. The idea that ancestral people only wandered without forming long-term communities simplifies a far more dynamic reality. They lived in ways that suited their environment, and those ways may not leave the kind of evidence modern archaeology relies on. Another layer to consider is the possibility that certain human groups reached levels of social organisation that didn't necessarily involve monumental architecture or heavy tools. A structured society doesn't require large stone buildings. It requires knowledge, cooperation, and the ability to adapt. These elements could have existed without leaving behind a stone marker. A community might have developed unique systems of navigation, fishing, farming on a small scale, or craft production that relied entirely on materials which have since decayed. If that community lived in a region affected by glacial activity, their tools, artwork, shelters, and everyday items could have been destroyed or buried where no one has yet looked for them. We often talk about archaeological discoveries as if they represent the full picture of ancient human life, but they are small snapshots preserved by chance. Most ancient memories are erased, reshaped, or lost. This isn't a failure of science, it's simply the nature of time and the environment. Only certain materials survive, and even those must remain in stable conditions for thousands of years. For much of Earth's history, stability was uncommon. Ice advanced and retreated many times. Volcanic eruptions covered regions in ash. Droughts transformed forests into deserts. Rivers changed course again and again. Each of these shifts removed layers of human presence from the landscape. Considering all of this, the possibility of a forgotten civilization becomes less about imagination and more about acknowledging the enormous gaps in what we can currently observe. Many of those gaps exist not because we have failed to look, but because the evidence simply no longer exists. The Ice Age was a sculptor capable of wiping entire worlds clean. When the glaciers carved their way across the northern continents, they carried everything with them. Soil, stone, plant material, and anything built by human hands were gathered, crushed, and redistributed. The retreating ice left behind new landscapes that bore little resemblance to what had existed before. Trying to reconstruct a human presence in such regions is like trying to reconstruct a city from the dust left after a storm. It isn't impossible, but it becomes exceedingly difficult. It helps to think about how recent some archaeological breakthroughs have been. Technologies like ground-penetrating radar, underwater mapping, sediment analysis, and genetic tracing have opened doors we didn't know existed a few decades ago. Before these tools existed, many ancient sites were simply invisible. Now we know that entire networks of human activity existed in places previously considered uninhabited. Forests have been found hiding ancient roads beneath their canopies. River valleys have revealed settlements preserved only by chance. Deep underwater regions have yielded evidence of human presence where no one expected it. These discoveries remind us that our understanding is limited by what we can access. If vast areas of early human activity lie beneath ocean waters or glacial remnants, they remain out of reach. Anything that existed there is hidden until new tools reveal it. Another point worth noting is that civilization does not always follow a linear path. Human societies progress, collapse, adapt, and reorganize in countless ways. There is no rule stating that complexity must come late in history, or that early groups were incapable of forming structured communities. If a group living before the height of the Ice Age developed a stable population, predictable food sources, and social organization, they might have created something we would call a civilization. Yet if their region was later destroyed by glacial movement or submerged under rising seas, nothing of that civilization would be visible to us now. History is written by what remains, not by everything that once existed. Some of the earliest known archaeological sites have already challenged earlier assumptions. People have discovered evidence of organised communities, symbolic behaviour, and large-scale cooperation far earlier than researchers once believed. With each new finding, the boundaries of possibility move slightly. These examples don't prove that a hidden civilization existed, but they show that humans have always been more capable and inventive than previous timelines suggested. If people tens of thousands of years ago could create complex structures or cultural practices, it stands to reason that similar achievements could have existed elsewhere and simply failed to survive environmental change. Thinking about all this invites you to picture a world where people walked across landscapes now buried under ice. Maybe they fished in rivers that no longer exist, or built shelters along coastlines long since drowned. They might have carved tools from materials that disappeared under pressure, or stored food in ways that left no trace. Their daily lives could have been filled with tasks, conversations, songs, and patterns indistinguishable from early human cultures we do know about. The difference is simply that their world was erased before modern humans had the chance to uncover it. Moving through these possibilities doesn't create a dramatic narrative. It creates a slow unfolding of perspective. The past becomes larger. The world feels more layered. Human history appears less like a straight line, and more like a series of chapters the Earth itself edited, erased, or left unfinished. With each consideration, the idea of a forgotten civilization becomes grounded in the simple understanding that the Ice Age was powerful enough to remove anything fragile from the world. Under the snowdrifts of memory, there may have been people whose lives left no surviving imprint, not because they were unimportant, but because the planet reshaped itself before their story could be preserved. Imagining the world before the last ice sheets reached their greatest size begins with understanding how different the continents looked. The planet has never been still, and during the glacial cycles, the shifting of water between land and ocean changed coastlines in ways that feel almost unbelievable today. It helps to picture the Earth not as a fixed stage, but as something always adjusting to temperature, sea level, and pressure. When the ice expanded, it locked vast amounts of water in frozen mass, lowering sea levels by over 100 meters. That simple fact transformed the geography of every continent. Regions now completely underwater once stood as wide coastal plains. Areas that today lie at the bottom of the ocean were once open fields, forests, and river valleys, forming meadows where waves roll now. Thinking of those lost landscapes helps set the foundation for what people might have done in them, and how easily their presence could have vanished once the ice began to melt again. During lower sea levels, continents were far larger than they appear on today's maps. The outlines we know are temporary, shaped by the rhythms of glaciation and retreat. If you were able to walk across Earth 20 or 30,000 years ago, you wouldn't recognise the shorelines. In Southeast Asia, enormous land bridges connected islands that now appear scattered and separate. Northern Europe had a coastline that stretched far beyond its modern boundary. The eastern coast of North America extended outward for hundreds of kilometres. These wide, flat regions would have held freshwater lakes, rolling grasslands, marshes where animals gathered, and rivers that cut through soft sediment long before seawater returned to cover the terrain. Many archaeologists believe that such areas would have been ideal for human life, offering abundant food, predictable seasonal cycles, and easy mobility across large open spaces. Taking a closer look at these vanished plains reveals a world where humans could have lived comfortably. Coastal regions often support fish, shellfish, game animals, waterfowl, and plant life that thrive in nutrient-rich environments. When sea levels were low, many of these resources concentrated along the slopes of continental shelves. The land there was neither too steep nor too barren. It would have been fertile, fed by rivers carrying minerals from inland mountains. Any group living in these areas would have found enough food to remain settled rather than constantly migrating. The idea of people forming stable communities in places now underwater is not only reasonable, it aligns well with what we know about human behaviour. People tend to stop moving when a reliable food source is available. They build, plan, develop skills, and pass knowledge down. All of this could have happened in regions we cannot access today. The picture becomes clearer when considering how much of these submerged landscapes remained exposed for thousands of years. During the last glacial period, sea levels stayed low for long stretches of time, giving people ample opportunity to adapt to the terrain. Rivers that now lie underwater acted as migration routes, guiding communities across wide regions of land. These rivers carved deep channels into the continental shelf, some of which can still be detected with contemporary sonar mapping. If people use these rivers as highways for travel, settlement or trade, traces of their activity may lie buried beneath thick layers of sediment. Since sediment accumulates rapidly in coastal environments, especially when meltwater floods carve through the terrain, any evidence of human life could be locked away beneath silt carried by ancient floodwaters. Something else to consider is how dry and expansive deserts could turn into fertile regions when global conditions changed. The idea of deserts becoming seas or meadows isn't meant as a metaphor. Climate cycles physically transformed these areas. Regions now known for heat and dryness experienced periods of regular rainfall during cooler glacial phases. When temperatures were lower, evaporation slowed and atmospheric patterns shifted, bringing moisture into areas that today receive very little. The Sahara, for instance, experienced multiple intervals when it held lakes as large as some modern inland seas. Grasslands, woodlands and marshes covered what is now a vast expanse of sand. In these wetter phases, the desert would have offered resources comparable to any temperate region: grazing animals, broad-leafed plants, freshwater pools, and predictable seasonal abundance. The same phenomenon occurred in other desert regions. Central Asia held extensive grasslands that supported large herds of grazing animals and the predators that followed them. Australia, often pictured as dry and unforgiving, also experienced periods of expanded wetlands and cooler climates that supported lush growth. North America's deserts, too, were transformed by glacial cycles. Ice Age lakes filled deep basins, creating enormous freshwater systems with shorelines stretching for hundreds of kilometers. These lakes lasted long enough for humans to use their resources, travel along their edges, and establish campsites or long-term settlements. The remnants of those lakes can still be traced in the form of ancient shorelines carved into the hills, salt flats marking their former floors, and sediment layers revealing repeated shifts between wet and dry periods. When you begin layering all of these changes together, the world becomes much harder to picture in simple terms. Everything depended on temperature, rainfall, wind patterns, and the movement of ice. These systems shifted in cycles that lasted thousands of years. During some intervals, a region could support forests and diverse wildlife. In others, it might dry out completely or become buried under ice. Humans navigating these cycles would have needed to adapt to dramatic environmental changes, moving in and out of regions as conditions allowed. If they lived in a wetter Sahara, for example, they might have created settlements around lakeshores or marshlands. When the climate shifted and the region dried again, their structures could have been abandoned, eroded, or buried beneath layers of sand carried by strong winds. Over time, dunes would have moved across the landscape, covering everything beneath them. Nothing short of targeted excavation or advanced remote sensing could reveal such sites today. Shifting climates also affected the behaviour of rivers. A river that flowed strongly during wet periods could shrink or disappear entirely when rainfall decreased. When rivers dried, their banks collapsed, vegetation receded, and animals dispersed. Without consistent water, human groups would have migrated with the changing patterns. If they left behind anything of value, such as tools or structures, those objects would sit in dry riverbeds or floodplains vulnerable to erosion. Flash floods brought by sudden storms could wash away any remaining evidence. Over thousands of years, shifting sands or sediments would bury what survived, creating layers that modern archaeologists must sift through to uncover isolated fragments of earlier life. The odds of finding a complete structure under such conditions are extremely low. Thinking about shifting deserts and sunken meadows changes the way we imagine early humans. They weren't always clustered in small, cold regions as common illustrations often show. They lived in environments that sometimes offered pleasant, abundant resources. They may have built homes in valleys that are now underwater, or lived near lakes that disappeared completely when climate cycles reversed. Their stories would follow the natural lines of the world, not the fixed borders we see today. As the climate shifted, they shifted with it. Their knowledge adapted to changing rainfall, vegetation, animal movements, and landforms. All of this suggests that early humans lived through constant environmental transformation. Any civilization, whether simple or complex, would have been shaped by these changes. Something else becomes clear as soon as you look at how humans respond to abundance. When people find stable environments, they begin to innovate. This doesn't mean building towering structures or forging metal. It can mean developing better fishing nets, gathering tools, pottery, simple agriculture, or methods of storing food. These are foundational elements of civilization even if they don't leave behind impressive physical structures. Pottery can be fragile. Tools made from plant fibers can vanish quickly. Wooden structures decay unless protected in unusual conditions. Without stable preservation environments such as caves, deep dry soil, or volcanic layers, fragile human creations disappear. If a group lived along a wide coastal plain that later flooded, everything they made could dissolve or scatter long before modern researchers had the opportunity to discover it. Coastal flooding is an especially powerful eraser. When sea levels rose at the end of the Ice Age, it didn't happen slowly at first. Melting glaciers fed enormous amounts of water into ocean basins, sometimes causing rapid increases over short periods. Rivers backed up, estuaries expanded, natural barriers collapsed, allowing seawater to rush into low-lying regions. Storms and tides would then shape the submerged land, breaking apart loose structures or scattering debris far beyond its original location. Even stone tools could be moved by currents strong enough to reshape seabeds. Over thousands of years, sediment accumulated in layers, covering everything beneath it in thick blankets that only deep underwater excavation could penetrate. As sea levels rose, some coastlines experienced dramatic erosion. Cliffs crumbled, hillsides collapsed. Soil containing organic material washed into the sea. If any ancient community had lived near such areas, their remains might have been torn apart long before being submerged. This process continued as the ocean pushed further inland. Areas once home to humans became underwater deserts, covered in silt and sand. The remains of their lives, if any survived, would be scattered so widely that assembling a clear picture would be nearly impossible without targeted discovery. It helps to step back and imagine the full extent of these transformations. Entire continents expanded and shrank as glacial cycles pulled water from the oceans and then returned it again. Regions that now seem permanent were temporary stages in a much larger cycle. Rivers shifted, deserts transformed into meadows, and coastlines stretched far into areas now underwater. People moving through these landscapes were responding to changes that shaped every generation. Their adaptability was their greatest strength, but it also means their presence may not have left behind structures durable enough to survive the shifting of the world. Everything about this era points to a planet constantly rearranging itself. Instead of stable environments that preserve human activity, the Ice Age offered long periods of calm followed by sudden shifts. Flooding, drought, storms, and ice movement erased delicate traces. If a small civilization developed on a coastal plain that now lies beneath the ocean, its memory could have been swept away before the last ice melted. If people built their homes near freshwater lakes that disappeared, their abandoned structures might lie beneath layers of sediment that no one has examined. If communities lived in deserts that once held grasslands, their presence could lie under dunes that have shifted countless times over thousands of years. Considering all of this, the idea that people lived and built in these forgotten regions becomes far more grounded. The landscapes themselves invite the possibility. The changing climate provides the context. The absence of evidence becomes a natural outcome rather than a contradiction. It's not that such civilizations didn't exist. It's that the world they lived in changed so completely that almost nothing could survive the transition. Stepping further into this idea means looking closely at what happens when time, pressure, and shifting landscapes work together to erase all but the smallest traces of human activity. It's easy to imagine footprints in soft soil or clay, a pattern of steps frozen in place after a passing moment. But when the world changes as dramatically as it did during the Ice Age, those simple marks become impossible to preserve unless extraordinary conditions protect them. Anyone who has walked along a beach knows how quickly footprints fade. One wave, a gust of wind, or a change in moisture erases them. Now imagine that kind of fragility spread across an entire world, facing advancing ice sheets, flooding plains, drying lakes, and shifting sands. Any signs of early people would have needed perfect conditions to survive. The idea of finding those faint impressions under layers built through thousands of winters becomes almost impossible without understanding the forces that shaped them. One important place to begin is with soil itself. Soil carries evidence of activity only when it remains undisturbed. The layers must stay intact, protected from wind, animals, and water. Yet during the Ice Age, stability was rare. Areas that were once grasslands could become frozen tundra. Stable riverbanks could shift into new channels. Wetlands might dry, crack, and blow away as dust. In colder regions, permafrost layers formed and thawed repeatedly as the climate fluctuated. Each change reshaped the ground. Even footprints pressed deeply into soft earth would break apart if the surface expanded, contracted, or froze. Over thousands of years, the earth itself would move enough to remove all signs that a person had ever stepped there. One of the most powerful forces of erasure was glacial advance. As ice sheets thickened and spread across northern regions, they acted like slow-moving bulldozers. Any ground beneath them was compressed under massive weight. Rocks ground against one another, sediment was scraped away, soil layers mixed together and spread outward in new formations. When the glacier eventually melted, the land left behind was not simply covered, it was rebuilt. Any trace of human footsteps or early settlements would have been ground into dust or mixed with sediment layers so thoroughly that it would be impossible to isolate them. The ice did not preserve, it reorganized. If people once walked across northern landscapes that later became the base of a glacier, those movements are now part of a geological memory rather than a human one. Rivers also played a large role in reshaping early traces. During glacial melt phases, enormous volumes of water poured across the land, carving new valleys and filling old ones. These meltwater floods sometimes rushed with the intensity of natural disasters. They swept away entire landscapes. Any footprints left near riverbanks or floodplains would disappear in moments during such events. Over time, as the water cut channels deeper into the land, the banks collapsed repeatedly. Layers buried any surviving impressions under thick sediment, but even that buried evidence would be disturbed by later floods. Each rise and fall of water rearranged everything from sand grains to large stones. Finding human traces in such environments would require identifying preserved pockets, untouched by the shifting flow. Those pockets are rare, and if they exist, they're often deeply buried beneath layers that no one has investigated. Deserts changed in equally dramatic ways. During colder, wetter periods, desert soils hardened with moisture and plant life. Footprints pressed in those conditions might survive temporarily. But later, as climates dried, winds picked up, blowing sand across the landscape in constant waves. Dunes moved for miles, burying anything in their path. The buried layers did not remain still either. Wind pressure causes dunes to shift internally. Sand grains travel upward or downward within the dune, breaking apart delicate impressions. Even in deserts today, it is difficult to find footprints more than a few years old unless they were preserved by unique conditions such as volcanic ash or hardened mud. Over thousands of winters, any sign of human passage would vanish. Some environments do preserve footprints for long periods, but they require unusual stability. Certain regions with volcanic activity have layers of ash that can harden quickly when wet. Footprints formed in this ash may turn to stone as minerals bind them into a durable layer. But volcanic conditions are rare, and their distribution does not align with the broad coastal plains and fertile regions where early people may have lived. Additionally, volcanoes bring their own destructive forces. Eruptions, lava flows, ash clouds, and landslides can obscure or destroy earlier traces. If early humans lived near such regions, the preservation of their footprints would be an exception rather than the rule. Another element to consider is how quickly natural processes can erase human presence. Modern abandoned towns show clear signs of decay within just a few decades. Walls collapse, roads crack, vegetation breaks through the structures. Given enough time, even metal objects corrode or break apart. If you extend that timescale into thousands of years, with glacial action, flooding, wind erosion, biological decay, and sedimentation, the chance of recovering intact human footprints becomes extremely small. This doesn't mean people weren't there, it simply means the conditions were not kind to fragile evidence. Archaeological discoveries of early human footprints are rare and usually preserved under very specific circumstances. Some examples exist in southern Africa, where footprints hardened in ancient mud after being exposed to sunlight and covered by additional layers of sediment shortly afterward. These discoveries required remarkable conditions that protected them from erosion. They survived only because later layers shielded them from wind and water. Similar discoveries in other regions resulted from volcanic ash or unusual mineral deposits. Without such protective layers, footprints would break apart long before anyone could examine them. If early people walked along coastlines now submerged, or across plains crushed by glaciers, no such protective layer would have preserved their tracks. Looking even deeper into the landscape, sediment cores reveal how much erosion occurred during glacial cycles. Scientists studying deep ocean cores have found layers of material washed in from continents during intense flooding periods. These layers tell us that sediment moved on a massive scale. If human footprints or early tools were mixed into these layers, they would now rest at the bottom of the ocean, scattered among clay and silt. Recovering them would be extremely difficult, and identifying them as human in origin would be even harder due to their fragmentation. The ocean floor remains one of the least explored parts of Earth, and deep cores taken from it show a continuous record of shifting continents and changing climates. Yet human traces within these layers would be indistinguishable, without a clear structure or recognizable form. This raises an important point about how archaeologists identify human activity. Tools and footprints are obvious indicators, but many signs of culture do not appear in stone or hardened surfaces. Fire pits, woven materials, temporary shelters, wooden structures, and organic tools all decay unless preserved by very rare conditions. If early communities used materials that decayed quickly, their existence might be completely invisible in today's archaeological record. Even stone tools are not guaranteed to survive. They can be carried by rivers, broken by pressure, or buried when no one has searched. In underwater contexts, currents and waves can scatter them widely. Without a cluster of objects to suggest a clear pattern, isolated fragments are often overlooked. It's also worth noting how little of the Earth has been examined thoroughly. Archaeological work is concentrated in regions where conditions favour preservation, or where human populations have remained stable for long periods. Forests, deserts, tundra, mountain regions, and the ocean floor remain largely unsearched. Many areas that might hold traces of early human activity are covered by dense vegetation, or lie beneath layers of soil too thick for casual examination. If footprints were preserved under these layers, they would require scanning technologies or extensive excavation to detect. Even then, the chances of finding intact impressions are extremely small. Beyond literal footprints, the idea of lost human activity extends to patterns of movement. Migration pathways could have existed along river corridors, coastlines, or valleys now transformed beyond recognition. People may have walked along routes where glaciers later advanced. Their trails would vanish as soon as the ice reached those regions. The concept of a human pathway erased by environmental forces is not speculation. It is a natural outcome of the geological processes active during glacial periods. While a physical footprint might not survive, the idea of people moving through those regions remains entirely plausible. Some evidence begins to emerge when looking at genetic markers in modern populations. Certain genetic signals suggest that ancient groups travelled across regions now underwater or now uninhabitable. These signals don't reveal exact patterns, but they hint at migrations that do not align with current geographical boundaries. Genetics cannot show where early people left their footprints, but it can reveal population movements that correspond with the existence of now-vanished landscapes. This supports the possibility that human groups lived in areas where environmental changes later removed the physical traces of their presence. When studying geological formations, researchers sometimes find disturbances in sediment layers that could have been caused by animals or humans. Determining the source of these disturbances is difficult because many creatures produce similar effects. A slight depression in the soil might come from a large animal or from natural settling. Without a clear pattern, such disturbances remain ambiguous. A few scattered indentations cannot be confidently identified as human footprints. Only a cluster with recognizable stride length, shape and depth can confirm human origin. Since glacial cycles rarely preserve such clusters, their absence does not prove that humans never passed through the region. It only reflects the challenges of preservation. Any discussion of lost footprints must also include the idea of submerged forests and valley floors. Tree trunks, plant roots and compacted soil have been found beneath shallow ocean waters in some regions. These discoveries show that land once existed where waves roll now. If people once walked in these areas, their footprints would have been covered by rising water and then destroyed by tidal action. Even stone surfaces underwater erode over time. The continuous movement of waves smooths out details. Fine impressions left by human steps would not survive long in such conditions. Considering these environmental forces highlights the gaps in our understanding. When people imagine looking for traces of ancient humans, they picture dry landscapes with clear layers of soil. But the truth is that Earth's surface is constantly reshaped. Wind carries sand, water carries sediment, ice crushes soil, vegetation grows and decays, animals dig and burrow, insects break down organic material, microorganisms decompose remains. Over thousands of winters, the combined effect of all these forces is enough to erase any shallow impression left by a person's foot. Instead of thinking about lost footprints as isolated marks in the soil, it may be more accurate to imagine them as part of a broader pattern of missing evidence. Footsteps represent movement. If early people moved through regions that later underwent dramatic environmental transformation, the absence of footprints does not contradict their presence. It simply acknowledges the power of natural forces over time. Traces that once existed on dry land may now lie beneath water, ice, or meters of sediment. With each passing century, the chance of recovering physical evidence becomes smaller. Looking at the broader picture, it becomes clear that the lack of direct physical footprints is not surprising. The conditions required to preserve even a single track are so specific that we should expect very few examples. Instead of searching for literal footprints, researchers look for indirect clues in soil chemistry, sediment disturbance, stone tool scatter patterns, and genetic signals. When considered together, these clues create a fragmented story. It is incomplete, but it suggests that movement occurred across a landscape now changed beyond recognition. Moving into the possibility of a civilization buried beneath ice requires shifting attention away from the familiar idea that human history is fully mapped. The more we learn about how landscapes transform during glacial cycles, the more it becomes clear that entire regions vanished under conditions harsh enough to erase nearly all traces of human presence. When ice advances, it does not act like snow accumulating on a quiet winter morning. It behaves more like a powerful engine grinding the ground beneath it. Imagining a culture caught in the path of such an event means accepting that silence in the archaeological record does not always reflect absence. Sometimes it reflects overwhelming forces that preserved nothing at all. A glacier advancing across a landscape behaves slowly, but with enormous pressure. Snow accumulates year after year until its weight compresses the lower layers into dense ice. Gravity then draws that mass outward from the accumulation zone. As the ice begins to move, it drags rocks, soil, vegetation, and anything built by humans along with it. The material caught beneath the ice is scraped, crushed, and often ground into fine sediment. Even large stones are reduced to smaller fragments. Soil layers mix together, forming compacted bands known as till. If any structures or cultural remains once existed in the ice's path, the pressure alone would be enough to flatten them. The grinding action would then scatter what remained across a wide area. This isn't a rare or unusual effect. It's a basic characteristic of glacial movement. The scale of these ice sheets is difficult to grasp without numbers. Some of the largest glacial formations reach thicknesses of several kilometers. Their weight deformed the Earth's crust, pressing it downward and creating basins that altered water flow. When ice of that scale moved across land, it reshaped everything. Valleys deepened, hills flattened, and bedrock fractured. If a civilization had built dwellings, storage pits, workshops, or even early forms of organized settlements in regions later overtaken by glaciers, none of those structures would survive intact. Anything made from wood, clay, reeds, animal materials or fibers would be completely destroyed. Stone, though harder, would not fare much better. Only the most durable bedrock carvings or deeply buried structures could endure such pressure, and even those would likely be unrecognizable after being dragged beneath moving ice. Considering these forces helps make sense of the silence left behind. It does not take speculation to imagine how traces of human life could vanish under such conditions. The environmental record shows many examples of landscapes wiped clean by glacial advance. Areas once home to ancient forests or wetlands today reveal only bare rock or thin layers of sediment. No trees, no soil, and no trace of earlier ecosystems remain. These observations provide a framework for understanding how thoroughly the ice could erase anything left by humans. If forests vanished, if soil vanished, if lakes drained and refilled with entirely new forms, then human creations, which are far more fragile than most natural features, would disappear even more easily. Climate patterns during the glacial cycles also reveal how unpredictable the world was. People living in these regions may have built communities during warmer intervals, only to face the gradual but unstoppable approach of colder conditions. At first, the change would have been subtle. Seasonal temperatures might shift, animal migrations could adjust, water sources might freeze earlier each year. Over generations, these changes could drive people to move downslope or toward milder areas. If they left behind structures, gardens, markers, or burial sites, those features would remain exposed until the ice reached them. Once the glacier arrived, the landscape would be remade. After thousands of years, when the ice finally retreated, the land would bear no resemblance to what had existed earlier. A researcher walking through that region today would not see eroded remnants of human structures. They would see a terrain carved by ice, dotted with erratic boulders and layered with glacial sediments. Under that scenario, the silence in the archaeological record is not mysterious. It is expected. Most evidence from early human activity relies on preservation through stable conditions. Glaciers do not offer stability. They offer destruction followed by reorganization. If a civilization thrived in regions later overtaken by massive ice sheets, its absence from the record reflects the natural outcome of physical forces acting over tens of thousands of years. Turning attention to how people might have lived in those areas before the ice arrived creates another layer of understanding. Humans tend to gather around reliable water sources, predictable food supplies, and moderate climates. During warmer phases of the glacial cycle, northern regions offered exactly those conditions. Rivers flowed freely, vegetation grew densely, herds of grazing animals occupied open plains, fish thrived in lakes and streams. A group settling in such an area could have flourished for many generations. They might have developed agriculture on a small scale or cultivated certain plants. They might have built permanent or semi-permanent dwellings using local materials. They could have created social structures, traditions, tools, and forms of cooperation suited to their environment. None of these choices require advanced technology. They only require time, stability, and access to resources. The eventual arrival of colder conditions would disrupt these communities long before the ice physically reached them. Winters would lengthen, summers would shorten, plant life would shift. People might migrate southward, abandoning the settlements they had built. As they moved, they may have carried knowledge and tools with them, but whatever remained behind would face exposure to harsh weather for decades or centuries before the ice arrived. Wind, rain, freezing temperatures, and animal activity could damage structures quickly. By the time glacial ice reached the area, little would remain standing. The ice would then eliminate all trace of what was left. Later, meltwater would carry sediment across the ground, burying the land under new layers. The transformation would be complete. This process raises a question about what kinds of human activity can survive such cycles. For the most part, only stone tools, deep hearths, or buried items stand a chance. But even stone tools can be scattered by glacial movement, making them difficult to identify. Hearths may be broken apart or washed away by meltwater. Buried materials may be crushed or dispersed. In some cases, glacial activity can preserve isolated artifacts by embedding them within layers of till. But such artifacts would be extraordinarily rare, and their discovery would require targeted excavation in locations not yet explored. Without knowing where to look, researchers may simply overlook areas where buried traces exist. The silence becomes more pronounced when considering how little exploration has occurred in regions previously covered by ice. Much archaeological work focuses on areas with long, stable histories of human settlement. Regions deeply affected by glaciation often appear barren or unpromising. Their soil layers are disrupted. Their surfaces show few clear signs of uninterrupted occupation. Researchers tend to prioritize regions where preservation is more likely. As a result, areas heavily reshaped by ice receive far less attention. This bias is understandable, but it means that potential traces of early human activity in glaciated regions remain undetected. The absence of evidence in these regions does not reflect lack of human presence. It reflects lack of stable preservation environments and limited exploration. Another important factor is the way glacial retreat shaped coastlines. As the ice melted, sea levels rose dramatically, flooding valleys and low-lying plains. Some regions that were once covered by ice are now underwater. Coastal erosion further removes surface evidence. Waves carved into newly exposed land, carrying sediment into deeper water. If any cultural material had survived the glacial period, the post-glacial flooding may have removed it. Even today, underwater archaeological exploration faces significant challenges. Deep-sea environments, strong currents, and buried sediment layers make it difficult to identify artifacts. Most underwater discoveries come from shipwrecks or structures preserved by unusual circumstances. Finding traces of early human activity within such dynamic underwater systems is extremely difficult. Understanding the scale of transformation highlights how easily silence emerges. If a group of people lived in an area that later became buried under thick ice, Their final traces would be erased long before modern researchers arrived. If they left behind carvings on rocks, those rocks may now lie far from their original location or show scars from glacial abrasion. If they built ceremonial structures, those structures could have been flattened or broken apart. If they stored food in pits, those pits may have filled with sediment and collapsed. Even bones, which can last for thousands of years under ideal conditions, degrade quickly in glacial environments. Pressure, moisture, bacteria, and freezing cycles would break down skeletal material within relatively short amounts of time. Despite all this, faint hints do appear occasionally. Some regions reveal isolated artifacts that seem older than expected or out of alignment with established theories. A few areas show disturbed soil layers that hint at earlier human activity. These clues do not form a complete picture, but they suggest that more may lie beneath the surface. The problem is that such hints are difficult to interpret without broader context. A single artifact does not confirm a civilization. A scattered set of stones does not indicate settlement. Researchers need patterns, repeated signs, and large groupings of artifacts. Glacial environments rarely preserve such patterns in recognizable form. Even so, the idea that entirely unknown groups lived in pre-glacial regions remains plausible. Human populations were widespread across Africa, Eurasia, and parts of the Americas long before the last glacial maximum. These groups were resourceful, adaptable, and capable of building communities. Their activity in some regions would leave behind traces, but in others it would vanish completely due to environmental shifts. The silence in certain geographical zones should not be interpreted as a denial of human presence. It should be interpreted as a consequence of natural processes that remove fragile evidence. Another factor that supports the plausibility of a lost civilization is the uneven distribution of archaeological discovery. Some regions have yielded extensive remains simply because they preserved well. Others appear empty because conditions allowed nothing to survive. This uneven distribution creates gaps in the story of human history. The missing pieces are not necessarily smaller or less significant. They simply exist in areas where the environment prevented preservation. Glaciated regions fall firmly into that category. If you imagine a settlement built in a sheltered valley during a warm interval, surrounded by rivers, plants, and animals, you can picture its slow disappearance. People eventually move away. The structures fall into disrepair. Weather breaks them down. Soil collects over them. Animals disturb the layers. Centuries pass. Climate shifts. Snow accumulates. The valley becomes colder. Ice forms. Over thousands of years, the glacier advances into the valley. Everything left behind is flattened. Later, meltwater floods the area, washing away scattered remnants. Sediment fills the valley floor. A new landscape forms. No visible sign remains that a community once lived there. This process repeats across entire continents. Valley after valley, plain after plain, region after region. The silence becomes not surprising but inevitable. A civilization buried under ice would leave almost nothing behind, not because it lacked complexity, but because the environment removed every delicate trace. Considering how these processes unfold directs attention toward what kinds of clues might still exist, not as artifacts but as subtle evidence embedded in geology or in the distribution of species. This provides a pathway to understanding how researchers might eventually detect faint signals of earlier human presence in regions shaped so heavily by ice. Understanding what remains after a civilization is buried beneath the ice requires paying close attention to what happens when that ice begins to melt. Meltwater is not simply water running off the surface of a glacier. It is a powerful force capable of reorganizing entire landscapes. It flows in channels beneath the ice, cuts through rock, fills temporary lakes, and releases suddenly when natural dams fail. These movements leave behind patterns that sometimes preserve faint clues about what existed before the ice took hold. These clues are rarely direct, but they can help form a clearer picture of the ancient world. When looking for human traces in a region once dominated by glaciers, meltwater becomes an important part of the story. It helps to begin by imagining the first stages of glacial retreat. As the climate warms, ice begins to thin at the edges and meltwater gathers on the surface. Channels form as the water flows downward, sometimes cutting several meters deep into the ice. The meltwater running underneath the glacier moves even more forcefully. It carries rocks, sediment and debris along narrow tunnels. When these tunnels collapse or widen, they deposit material in irregular layers. Later, when the glacier fully retreats, these deposits remain as long, winding ridges of gravel and sand. These features, called eskers, sometimes contain stones or sediments from far distant regions carried by ice and water. While eskers do not directly record human activity, they show how material from earlier landscapes can be transported and preserved in new geological formations. If a region once held tools, bones or structures before the glacier advanced, meltwater might move some of that material and deposit it elsewhere. It's unlikely that these objects remain intact, but small fragments can survive. In rare cases, meltwater might carry stone tools without breaking them. These tools could then rest within layers of sediment that later solidify. Discovering such a tool would provide evidence that people were present in the region long before the glacier arrived. Yet most meltwater deposits have never been studied closely, partly because they appear chaotic and partly because they often lie in remote locations. The complexity of these deposits makes it difficult to interpret any isolated find. Even so, this process shows that fragments of earlier human activity might survive indirectly, carried by flowing water and preserved only by chance. During glacial retreat, large lakes often formed along the edges of the ice sheets. These lakes were temporary. They existed only as long as the ice blocked the flow of rivers. Once the blockage melted or geological pressure caused the lake to drain, enormous amounts of water rushed through valleys and plains. These floods could reshape entire regions in a matter of hours. They eroded soil, carved deep channels, and scattered boulders over wide areas. If sediment layers within these floodplains contain unusual concentrations of charcoal, organic residue, or fragmented stone, they may hint at earlier human activity. These hints are subtle and require detailed analysis. They also require acknowledging that the land where evidence once lay is no longer the same land researchers examine today. Meltwater can also create stable environments in which faint traces survive longer than expected. For example, when meltwater flows into depressions and forms shallow ponds, these ponds sometimes accumulate layers of silt that build slowly over time. If organic material becomes trapped within those layers, it can remain preserved for thousands of years. Researchers have found pollen grains, plant fragments, and small remains of insects in such deposits. While these finds do not confirm human presence, they help reconstruct the environment of the time. Understanding the environment is essential for predicting where people might have lived. By examining the types of plants and animals present, researchers can identify areas that would have supported human life. If a pond contains evidence of steady vegetation and stable conditions during a warm interval before glaciation, it increases the likelihood that the surrounding region attracted human groups. Another phenomenon worth examining is the way meltwater smooths and polishes surfaces. When water-carrying sediment flows rapidly under glacial ice, it grinds the bedrock beneath it. This abrasion removes earlier marks but can leave behind shallow depressions or chemical signatures. In some rare cases, if a carved stone or worked surface lay protected beneath debris during glaciation, meltwater might have polished it without destroying its overall shape. Researchers sometimes discover stones with unusual patterns or wear that suggest human modification, though the context can be so altered by water and ice that confirming human origin becomes difficult. Still, these isolated finds raise questions about what might be hidden beneath deeper layers. Looking more closely at the sediments left behind by meltwater reveals additional clues. When meltwater deposits fine layers of silt, each layer records conditions at the time of deposition. Variations in mineral composition, colour and grain size reflect changes in water flow and source regions. Occasionally, researchers identify layers containing charcoal, suggesting fires occurred before glaciation or during brief warm intervals. Since fires can result from natural causes or human activity, charcoal alone does not confirm the presence of people. But when combined with other evidence, such as distinct changes in vegetation or unusual concentrations of certain minerals, it becomes part of a larger pattern. These patterns sometimes indicate that humans were shaping the landscape in subtle ways long before the ice arrived. One of the more surprising sources of information from glacial environments is preserved animal remains. While human remains rarely survive such conditions, bones of animals sometimes do, especially when they become trapped in cold environments with limited oxygen. Studying these remains can reveal hunting patterns, migration changes, or sudden die-offs associated with environmental shifts. If animal remains show signs of butchering or tool marks, they directly indicate human activity. The problem is that such traces are extremely rare in glaciated regions. Still, a few documented examples exist, and they demonstrate that not all evidence disappears completely. Even isolated findings of animal bones with tool marks offer insight into how people might have lived near the edges of ice sheets. Another important aspect of meltwater is its ability to reveal older layers through erosion. As water cuts through sediment, it sometimes exposes buried surfaces that might have been stable before the glacial cycle. If people lived on such surfaces, faint signs might still exist. For example, a fire pit or compacted area where people gathered might be preserved as a discoloured patch beneath newer layers. Meltwater erosion can expose these patches in cliffs or riverbanks. When researchers identify such anomalies, they often investigate further to determine whether the discoloration results from natural or human causes. While many such features turn out to be geological, some have yielded evidence of early human presence. These discoveries remind us that meltwater, though primarily destructive, can occasionally reveal the past in unexpected ways. Large-scale meltwater floods also leave behind terraces and stepped surfaces along valley walls. These terraces are composed of sediment deposited during different stages of flood activity. If researchers find repeated layers showing similar patterns of disturbance, it may indicate that people returned to the same area during multiple warm intervals before glaciation. Such recurring activity would suggest a degree of settlement rather than random movement. Terraces can also trap organic material in pockets protected from erosion. In rare cases, plant fibres or small fragments of tools have been discovered in such contexts. These discoveries are difficult to interpret without broader evidence, but they show how meltwater shapes not only the land but the record of what once existed. Reflecting on meltwater as a source of clues highlights the complexity of reconstructing human activity in regions transformed by glaciation. Meltwater does not leave behind straightforward evidence. It scatters, mixes, erodes, and deposits. It hides some traces while revealing others. Its effects are unpredictable. But within this unpredictability lies the possibility of discovering the smallest echoes of past lives. When researchers sift through these deposits, they search for anything that stands out from the natural background. A single flake of stone showing human craftsmanship, a cluster of charcoal particles in an unexpected layer, or an unusual pattern in soil chemistry can point toward a human presence no longer visible on the surface. Understanding how these small clues form also shows the limits of current exploration. Many meltwater features lie in remote areas far from modern populations. Some are buried under dense vegetation. Others lie deep within riverbanks or beneath lakes formed long after glaciation. Excavating such areas requires time, resources, and specialized equipment. For this reason, many promising regions have never been explored. The silence left by glaciation is partly due to the destructive power of ice and water, and partly due to the difficulty of conducting research in such challenging environments. As the idea of echoes in the meltwater becomes clearer, the story shifts toward how these faint signals connect to the broader question of whether a civilization could have existed before the ice erased its presence. Meltwater deposits do not provide full answers, but they offer glimpses of the landscapes people might have known. They reveal how environments changed, how animals moved, how vegetation shifted, and how water shaped the terrain. Each of these factors contributes to understanding where people might have settled, and how their traces could have been removed or buried. Moving through this understanding brings attention to a larger question. If meltwater carries echoes of the past, then what remains hidden in the landforms built by ice itself? What shapes, ridges and deposits might record subtle hints of human activity without revealing anything directly? Exploring the idea of maps erased by ice begins with recognizing that landscapes hold information even when no human drawings or markings remain. A map does not always need to be ink on a surface. It can take the form of familiar pathways, gathering places, river corridors, sheltered valleys, or open plains that once guided people from one place to another. These natural features acted as the earliest forms of orientation. When the world changes dramatically, the geography that once shaped those paths changes as well. The lines people followed, the boundaries they recognized, and the regions they understood become hidden under new formations. Glacial cycles have the effect of clearing the slate. They rebuild hills, carve new channels, and flood old ones. They bury valleys in sediment. They raise new ridges where none existed before. Imagining a culture living in such shifting environments means accepting that their maps, whether physical or internal, would disappear. Looking at ancient landscapes through the lens of modern mapping highlights how much is lost. Today's coastlines, river networks, and mountain arrangements differ from their pre-glacial forms. Some regions visible now did not exist thousands of years ago. Others that were once central to daily life lie underwater or beneath layers of sediment. People living before the last glacial maximum would have navigated terrains shaped by older climatic phases. Their understanding of the world reflected the conditions of their time. When the ice advanced, the land they knew changed so completely that no trace of their geographical knowledge survived. Even if they had drawn maps on durable materials, glacial pressure, flooding, and erosion would have removed them. Considering this helps explain why so much of early human activity remains invisible. It is not only the physical remains that vanish. The mental maps that guided people through their environments also disappear. These maps might have included known water sources, seasonal migration patterns, safe routes through hills, or areas rich in plants and animals. None of these would leave lasting marks unless repeated activity formed well-worn paths. But paths are among the most fragile features in the archaeological record. When soil shifts, vegetation grows, or ice presses downward, those lines vanish. The ground resets itself. A modern observer walking across that landscape would have no indication that people once walked there for generations. There is another aspect to this idea. Maps often reflect social connections. They show where groups travel, where they meet other communities, and where seasonal changes direct their movements. If a civilization existed in pre-glacial regions, its map would not only show physical features, it would include knowledge of alliances, trade routes, and areas shared or avoided by different groups. Such information becomes lost not because it is erased directly, but because the people who held it no longer inhabit the region. Their descendants might have carried fragments of that knowledge into new lands, but without the original geography, those fragments lose their anchor. Over thousands of years, such intangible maps fade. Turning attention to how the ice altered actual terrain makes the loss clearer. Glaciers not only flatten landscapes, they also produce new ones. As they retreat, they leave behind moraines composed of rocks and sediment carried across large distances. These piles can reshape valleys and create new topographical features. If you imagine a river that once flowed cleanly through a flat plain, a glacier might block its course with debris. After the ice melts, the river may carve a new path that bears no resemblance to its earlier route. any settlement built along the original riverbanks would be left far from the new waterway, or buried under layers of displaced material. The map of that civilization becomes irrelevant, because the terrain it described no longer exists. Rivers also change direction as ice shifts. Meltwater floods carve deep gorges in places where no channels existed before. In some regions, entire drainage patterns reverse direction. A group relying on a particular water source would have found their understanding of the land overturned by such changes. Understanding these dynamics provides a sense of how easily a culture's entire geographical framework can disappear. Without stable landmarks, even later populations would be unable to reconstruct earlier pathways. In coastal regions, the changes were even more dramatic. As sea levels fell during glacial peaks, wide plains emerged. People living at the time could have walked across land that is now submerged under tens of meters of water. When the ice melted and sea levels rose, those plains flooded. Coastlines receded inland, sometimes by hundreds of kilometers. Any settlements, gardens, or pathways built along those earlier shores would now lie underwater. The ocean floor does not preserve pathways well. Currents wash away loose sediment. Waves erode shallow regions. Marine organisms disturb layers. Only rare pockets remain untouched. Without consistent preservation, the geographical knowledge of pre-flood populations disappears completely. A coastline that once shaped an entire society's sense of direction leaves no sign of its former outline. Examining glacial deposits offers additional insight. Sediments carried by ice can bury earlier surfaces beneath meters of material. A valley floor that once held a village might now lie beneath glacial till. The original topography becomes too deep for casual exploration. Even advanced remote sensing may not reveal the buried terrain if the layers are thick or uneven. The map of that valley, a map formed through lived experience, is now inaccessible. Only by excavating through large amounts of debris could researchers begin to uncover the older surface, and such work is extremely rare. Most regions affected by glaciation contain landforms so heavily reorganized that reconstructing earlier topography requires extensive modelling. Researchers sometimes attempt to recreate lost landscapes through geological data. They examine sediment layers, study the shape of ancient riverbeds, and analyse mineral patterns to estimate where water once flowed or where vegetation grew. These reconstructions can reveal broad outlines of pre-glacial geography, but they cannot restore the full picture of how people understood these regions. A geological map is not a cultural map. It shows shapes, but not meaning. It shows terrain, but not memory. Without human input, the map remains incomplete. This gap between physical reconstruction and cultural understanding defines much of the challenge in studying early civilizations that may have existed in glacially transformed regions. Another consideration lies in the formation of periglacial landscapes. These are regions adjacent to glaciers that experience intense freeze-thaw cycles. The ground expands and contracts repeatedly, causing the soil to move and forming patterned surfaces. These patterns create rings, stripes, and circles in the soil, none of which reflect human movement. Instead, they distort earlier traces and make it difficult to distinguish natural formations from cultural ones. If pathways or gathering areas once existed in these regions, the freeze-thaw cycles would disrupt them. The surface would reorganize itself until nothing recognizable remained. The idea of maps erased by ice becomes more interesting when considering how early humans may have navigated through such environments. Without preserved paths or structures, researchers must rely on environmental models that show where people would likely have travelled. These models consider water sources, animal migration routes, and climate patterns. They help identify corridors where people might have moved, but they cannot reveal the specific knowledge held by those populations. For example, if people use particular rock formations as landmarks, those formations might have been removed or relocated by glacial movement. If they followed a narrow valley that no longer exists, the valley's memory disappears with the terrain. Examining the preservation of glacial erratics provides additional hints. Erratics are large boulders carried long distances by glaciers. While their position today reflects movement under ice, their presence can obscure earlier landforms. A settlement built near a recognisable outcrop might become hidden beneath erratics, deposited during retreat. These boulders rearrange the visual structure of the land, making it difficult to identify earlier landmarks. A region covered with erratics looks nothing like its pre-glacial counterpart. Anyone attempting to reconstruct a map from such a landscape must strip away the glacial rearrangement layer by layer, a task often beyond the scope of conventional archaeological work. Another important consideration is how the ice sculpted mountains. Sharp peaks became rounded, ridges changed shape, deep U-shaped valleys formed where narrow V-shaped ones once existed. Such changes erase earlier routes through mountain passes. If people once used a narrow passage to move between regions, the ice might widen it, deepen it, or relocate the barrier entirely. The resulting valley tells only the story of glacial movement. It does not preserve the older pathway. Researchers must rely on indirect evidence to infer how earlier populations moved through mountainous terrain. Turning to underwater regions, sonar mapping sometimes reveals submerged channels and ancient river systems. These channels suggest where people might have settled in the past. If a river once flowed across a wide plain now under the sea, there may have been fertile land along its banks. In some cases, sonar data reveals terraces or flat surfaces consistent with human use, but interpreting these features is challenging. Natural processes can create surfaces resembling human-modified areas. Without direct excavation, confirmation remains uncertain. Even if researchers locate an ancient shoreline with promising features, recovering artifacts from such depths requires specialized equipment. Few underwater sites offer stable conditions necessary for preservation. The absence of maps becomes even more understandable when looking at how early humans may have shared geographical knowledge. Many societies relied on oral tradition rather than written records. These traditions connected stories to landmarks, seasonal changes and travel routes. If a landmark disappeared due to glaciation, the story associated with it would lose context. Over generations, the story might fade or change, breaking the chain of transmission. If the people migrated, their orientation system might shift to match the new landscape. After many centuries, nothing remains of the original map. The only surviving fragments might be general references to distant regions or lost lands, stories that become difficult to interpret in a modern context. Some regions contain ancient carvings or etchings on stone surfaces that could be interpreted as early maps, but most such carvings exist outside heavily glaciated zones. Regions exposed repeatedly to ice movement show far fewer such markings. The scarcity of carved or inscribed stone in these regions is not evidence of absence. It reflects the destructive nature of ice. Even if early people carved symbols or maps into exposed rock surfaces, the ice could remove or erode them. Meltwater channels could smooth the surfaces. Frost cracking could fracture the stone. Vegetation taking root after glacial retreat could obscure or break apart engraved surfaces. Without preservation, these markings disappear. Looking at patterns in the distribution of certain stone materials can also hint at lost pathways. When archaeologists find similar stone types spread across a wide region, they sometimes infer that people transported them over long distances. If these stones appear in areas affected by glaciation, the transport patterns might reflect movements of people through landscapes no longer visible. But interpreting such patterns requires caution. Glaciers themselves transport stones. Distinguishing human movement from natural movement is difficult when both create similar distributions. This overlap adds another layer of silence to the record. Understanding how maps disappear also involves considering how populations shift after environmental changes. When the ice retreats, new land becomes available. Lakes form, forests grow, animals move into new territories. People adapt to the changed landscape rather than attempting to reconstruct the old one. Any earlier map becomes irrelevant. New pathways emerge, shaped by post-glacial conditions. Over time, people forget the older routes. Knowledge becomes tied to the new geography. Even if earlier maps had survived physically, their relevance would diminish as the world changed. Reflecting on all these factors brings the idea into focus. Maps that once existed in the minds of early populations are gone because the land they described has changed too drastically. Glacial forces removed the landmarks. Floods altered the watercourses. Rising seas submerged plains. Hills shifted. Valleys disappeared. Without consistent geography, a map loses meaning. Without meaning, it cannot be preserved through memory. Without memory, it fades from history. Thinking about stones as carriers of stories begins with recognizing how much information they can hold. Stone can record pressure, heat, wind exposure, water flow, and even the marks left by human hands. For early cultures, stone was one of the few materials durable enough to survive beyond a single generation. People shaped stones to make tools, carved them to leave messages, or arranged them in ways that structured their daily lives. Yet even with that durability, stone remains vulnerable when exposed to storms, floods, shifting soil, wind erosion, and the harsh cycles of freezing and thawing. A landscape shaped by repeated glaciation and climatic instability becomes a place where even the hardest materials eventually lose their form. Recognizing that stones once held stories does not mean assuming those stories still exist. It means understanding how easily they can vanish. Starting with stone tools, one of the most common forms of evidence for early human activity, reveals how vulnerable they can be. A tool shaped from flint or obsidian can fracture when dropped or struck. It can be carried away by water or buried beneath accumulating sediment. Over thousands of years, pressure from overlying soil layers can cause even dense stone to break apart. In glaciated regions, ice movement grinds stones against each other until their surfaces become scratched or polished, erasing the marks that once signalled human craftsmanship. If a group built a toolkit of blades, scrapers, or points, and those tools were left behind as the climate shifted, storms and erosion could scatter them across large distances. A modern researcher might encounter one fragment, but miss dozens more. Without a clear pattern, a single fragment cannot tell a complete story. When considering larger stone structures such as alignments, walls, or platforms, the vulnerability increases. Early communities may have used stone to anchor shelters, stabilize cooking areas, or mark boundaries. These arrangements would have been meaningful to the people who built them, but their survival required stable conditions. Storms have the power to undermine any stone arrangement not deeply embedded. Heavy rains wash soil away from the base of stones, causing them to collapse. Floodwaters can lift smaller stones and carry them downstream. Wind can fill structures with sand, covering them and creating an appearance of natural mounds. Over many centuries, vegetation spreads roots through stone alignments, forcing them apart. If the environment experiences multiple cycles of such disturbances, the original structure becomes impossible to distinguish from natural rock formations. Another factor is the way stones weather over time. Erosion gradually softens edges, removes sharp cuts, and blends carved surfaces into smoother shapes. The difference between a naturally fractured stone and one shaped intentionally becomes difficult to tell when both have undergone thousands of cycles of rain, snow, heat, and freezing temperatures. Sand carried by wind can scratch surfaces. Acidic rain can dissolve certain types of minerals. Glacial meltwater can smooth even hard stone until markings disappear. When erosion reaches this level, any human story embedded in the stone becomes a pale trace, too faint to interpret. There are regions where stone carvings have survived, but these usually involve stable environments. Dry caves, sheltered cliffs, or deep valleys with little direct exposure to storms offer long-term protection. In contrast, regions affected by repeated glacial cycles present unstable surfaces. A carving made in a sheltered area might survive a few centuries, But if that shelter collapses in a storm, the carving becomes exposed. Once exposed, storms work quickly. A single year of frost cracking can cause large sections of the carving to break off. Water seeps into fractures, expands when frozen, and pries the rock apart. Once pieces fall, their context changes. They may roll downhill, tumble into streams, or break on impact. The carving becomes fragmented and scattered. A modern observer might find a piece and identify its significance, but without the rest of the carving, its meaning remains incomplete. It is also useful to consider how storms influence sediment layers that bury or reveal stones. During heavy rainfall, soil erosion accelerates. Steeper slopes become prone to landslides. Stones embedded near the surface may slide downward with loosened material. Over time, an entire stone structure can be relocated or buried in a new position. This displacement makes it difficult to pinpoint its original purpose. Storm-driven flooding can deposit thick layers of silt over an area, creating a new surface above any stones left behind. These buried stones remain hidden unless modern excavation reaches the correct depth. Since many regions shaped by ice and storms contain thick layers of mixed sediments, identifying the layer that corresponds to early human activity becomes challenging. Looking more closely at how rivers shape stone landscapes provides additional insight. Rivers shift course naturally, especially in flood-prone regions. During the Ice Age, meltwater floods introduced massive amounts of sediment into river channels. As rivers changed direction, they eroded some areas and deposited new layers in others. Stones arranged near older riverbanks would be scattered when water undercut the soil. Smaller stones might end up downstream. Larger stones might remain in place but lose their original alignment. Over time, the river might move entirely, leaving an altered floodplain that no longer reflects the earlier landscape. Without understanding the past position of the river, researchers examining the modern terrain would not see the original arrangement of stones. Storms do more than move stones. They also disrupt soil chemistry. When heavy rainfall leaches minerals from the soil, it can preserve some materials while degrading others. A stone that appeared dark when originally placed may lighten over time as minerals wash out. If early people used pigment on stones, storms could wash the colour away within a few seasons. Organic binding materials would break down even faster. The visual cues that distinguished a stone's cultural significance would fade long before the stone itself eroded. In some parts of the world, early cultures created cairns, stone circles, or mounds built from stacked rocks. These structures may have served ceremonial, navigational, or practical purposes. They depended on stable ground. Over thousands of years, repeated storms could undermine the base of such a structure. Stones would fall outward. Animals might dislodge smaller pieces. Freeze-thaw cycles could further destabilize the arrangement. A once organized structure would become a scattered pile. Without knowing the original arrangement, the pile might be dismissed as a natural rockfall. This demonstrates how quickly human design can become indistinguishable from natural processes. Turning to mountains shaped by glacial action, the difficulty increases. Glaciers scrape stones across long distances, leaving behind striations and polished surfaces. If early people carved symbols into stone in a mountain pass, the glacier would remove them. Any stone left behind after the glacier retreated would show only marks of ice movement. Researchers examining such stones today would see patterns consistent with glacial abrasion. The earlier carvings and the stories they told would be gone. In some cases, glaciers carry stones from one region to another, depositing them far from their original context. These glacial erratics confuse the geological record. A stone carved in one location might be transported to another, and any remaining marks would be faint or broken. Identifying the stone as part of a human story becomes nearly impossible. Windstorms in open plains create additional layers of complexity. Over time, wind moves sand and dust across large areas. Stones exposed to constant abrasion develop rounded edges. If the stone once held a sharp carving or a tool mark, Wind erosion can smooth it until the marking disappears. Sand can also accumulate around stones, burying them entirely. When wind later removes sand from the area, the stone becomes exposed again, but now appears out of context. This cycle of burial and exposure can repeat many times. Each phase alters the stone's relationship to surrounding features. Without a clear context, determining whether it was part of a human structure becomes difficult. Considering coastal storms adds another layer of understanding. When sea levels rise, waves begin to impact areas that were previously inland. Storm surges can push stones inland or pull them outward to sea. If early people arranged stones along a coastline, these arrangements would be vulnerable to wave action. Once the stones enter the marine environment, they erode even faster. Constant wave movement smooths edges. Saltwater weakens certain mineral bonds. Barnacles, algae, and marine organisms attach to the surface, obscuring any markings. Over centuries, the stone becomes unrecognizable. If the coastline later recedes due to geological uplift or changes in sea level, the now eroded stones may sit inland again, looking natural rather than cultural. Collapses caused by severe storms also play a role. Heavy rainfall weakens cliffs, rocks fall. If early people carved into cliff faces, those carvings might fall with the stone. The fallen blocks break upon impact, fragments scatter across the slope. Later storms move them further, vegetation covers them, soil accumulates. The carving becomes a set of fractured shapes no longer identifiable as human work. Without a full reconstruction of the broken pieces, the story remains lost. Another important aspect involves the difference between intentional modification and natural formation. Nature produces many forms that resemble human activity. Stones eroded by water can have smooth edges similar to ground tools. Rocks fractured by freeze-thaw cycles can mimic flakes produced by stone napping. When storms reorganize these stones, placing them in unusual patterns, modern observers might misinterpret natural formations as cultural or overlook cultural materials as natural. The ambiguity created by erosion makes interpretation difficult. If a civilization once used stones in ways not easily distinguishable from natural features, storms and environmental change amplify the confusion. It is also helpful to consider how early humans might have used stones that leave no obvious lasting marks. Many activities require simple tools that show little modification. Hammerstones, grinding stones, and anvils can resemble common rocks. Without wear patterns or residue preserved, these stones blend back into the environment. If storms moved them even slightly, the context that could have helped researchers identify them as tools disappears. A stone lying near a hearth might show clear evidence of use, but a stone moved far from the hearth by erosion becomes just another rock. Another point that deepens the idea is that early stone stories were often part of broader landscapes. People might have used natural stone features as meeting points, markers, or ceremonial locations. Over time, storms could damage these features. Rivers might undercut a cliff. Frost might break slabs away. Once the surrounding stone formations change, the cultural significance becomes hidden. Without the original context, even intact carvings lose their meaning. Researchers can identify the carving but cannot reconstruct the environment that gave it purpose. Understanding how storms erase stories carved in or arranged with stone highlights why so little remains from early civilizations that may have existed in unstable environments. The natural world does not preserve everything equally. Some areas protect remains well, others do not. Regions shaped by repeated glacial cycles fall into the latter category. The silence in the archaeological record reflects the relentless action of water, ice, wind, and time. Recognizing this silence shifts attention to deeper questions about what else might remain in forms that have not yet been studied or that require different methods to detect. Stones can lose their markings, but sediments can preserve chemical traces. tools can vanish, but patterns of soil disturbance can persist. Stories carved into stone can erode, but unusual alignments of natural features can hint at earlier human choices. Thinking about the remains of cities that may have existed before the ice reshaped the Earth means approaching the idea slowly and methodically. It begins with acknowledging how fragile early built environments can be. Even the word city carries assumptions shaped by modern architecture, organised street systems and durable materials. But the earliest cities in human history did not resemble the ones we know today. They were clusters of dwellings, storage areas, gathering spaces, workshops, or shared structures built from whatever materials were available. They may have included organised layouts, but those layouts did not need stone foundations, roads, or permanent monuments. When imagining ancient cities erased by glacial cycles, it is not useful to picture towering buildings or fortified walls. Instead, it is more realistic to picture communities where the essential structure came from repeated use, familiar pathways, and simple construction. These patterns leave subtle traces at best, and in unstable environments, even those traces disappear. Any community that reached a level of organisation beyond scattered wanderers could qualify as a small city. People living close together require ways to store food, manage water, coordinate group activities and support one another. They create shared spaces where people gather. They build structures that allow for privacy or security. They cooperate in daily tasks and build local networks. These patterns produce a kind of skeleton beneath the surface, a recognisable arrangement of repeated behaviour. Over time, the skeleton becomes a set of foundations, compacted paths, structural depressions, and worn activity zones. Archaeologists often rely on these signatures to detect ancient settlements. But when a powerful set of environmental forces arrives, it can erase even these foundational patterns. To understand how a city might disappear entirely, it helps to imagine its early form. Suppose a group built homes from wood, clay, reeds, or woven plant materials. These materials degrade quickly unless buried in dry or sealed environments. Rain weakens them, sunlight dries and cracks them, insects and microorganisms break them down, storms pull them apart. Over many centuries, nothing recognisable remains. Even hardened clay bricks or tiles can dissolve when exposed to repeated cycles of freezing and thawing. If a settlement depended on such materials, its physical remains would be vulnerable long before any ice approached. Now imagine this settlement located in a fertile region during a warm interval, before the ice advanced. Families built homes, people gathered to trade, food storage areas were maintained, simple workshops produced tools, containers or textiles. Over generations, these activities created a structured environment even if the buildings themselves were modest. Yet as the climate shifted, the region gradually became colder. Rivers froze earlier each year. Plants changed their growing cycles. People might have tried to adapt temporarily, but eventually they would leave the settlement behind. Their departure would mark the first stage in the dissolution of the city's physical identity. Once abandoned, the settlement would quickly become part of the natural landscape. Vegetation would grow through any remaining structures. Wind would scatter debris. Animals would burrow into the soil. Floods might wash away the lighter materials. Soil would accumulate in some areas and erode in others. If the settlement sat near a river, seasonal flooding might disperse its remains. If it lay in a valley, landslides could bury it. If it rested on a plain, wind-driven soil might cover the foundations, creating a natural layer that hides the earlier construction. These changes would occur long before the ice ever touched the region. When the glacier finally arrived, the settlement would face forces far more destructive than normal weather. Even if some foundations remained, the glacier would flatten them. It would mix soil layers, disrupt any remaining structure, and scatter stones or debris. After the glacier moved across the area, the original layout of the settlement would be unrecognisable. When the ice later retreated, meltwater would wash across the exposed ground. Sediment layers would form. Rivers would carve new channels. Vegetation would eventually return. The landscape would bear little resemblance to the one that supported the city. For researchers thousands of years later, no obvious signs would remain. This process applies not only to small settlements, but potentially to larger ones as well. A community that reached a higher degree of complexity might have built more permanent structures. They may have used larger stones, compacted earth, or reinforced frameworks. But even sturdier materials face limits. Stone walls collapse, earthworks erode, storage pits fill with sediment, fire-hardened clay breaks down under repeated freezing cycles. When ice presses down on the land, any remaining structures buckle and distort. Afterward, water carries away loose materials. Some pieces may remain buried deep beneath layers of sediment, but without clear organisation, they no longer provide an identifiable signature. The idea that a city could disappear in this way becomes more reasonable when looking at examples from known history. Some ancient settlements built from durable materials have been lost under far less extreme conditions. Entire river-valley civilizations disappeared under layers of silt after changes in water flow. Some desert cities vanished under shifting dunes. Volcanic eruptions buried towns so completely that their existence became unknown for centuries until excavation uncovered them. If such cities, built with more durable materials and at more recent times, could vanish so thoroughly, cities built long before the last ice age would be even more vulnerable. The bones of a forgotten city might include more than buildings. They could include agricultural fields, irrigation channels, or storage areas. These leave patterns in soil chemistry, but only when soil layers remain undisturbed. Glacial movement mixes soil layers thoroughly, removing chemical signals. Flooding washes nutrients away. Vegetation regrowth changes the soil composition. Unless the original agricultural patterns were preserved in a protected layer, nothing remains to identify them. The fields that once fed a community become indistinguishable from natural grasslands. It is also important to consider that early cities may not have relied on stone for building. In many early societies, permanent structures were made from wood. Large wooden posts could support roofs or platforms, but wood decays quickly unless waterlogged or sealed from air. In wet conditions, microorganisms break down wood within decades. In cold conditions, expansion and contraction weakens it. In dry conditions, cracking occurs. When storms or floods move through, wooden elements break apart easily. After a few centuries, nothing recognizable remains. When ice later presses down, it removes even the possibility of indirect preservation. If early cities existed along coastlines that later flooded, their remains would have faced a different set of destructive pressures. As sea levels rose, waves would break down structures. Tides would move lighter materials. Stones would be scattered across the shifting shoreline. Eventually, the city would submerge. Once underwater, currents could rearrange any remaining material. Marine life could destabilize buried layers. Sediment would accumulate over the submerged remains. Deep layers might protect some artifacts, but without a clear layout, even these artifacts would not reveal the original structure. Modern underwater exploration rarely reaches depths where pre-glacial coastlines now lie. The chance of encountering the bones of such cities remains small. Another consideration is that early cities may not have had large populations. A settlement of a few hundred people could still have functioned as a city if it had organised tasks, specialised roles and shared infrastructure. Such a community would leave behind far fewer artefacts than a larger population. When environmental forces scatter or destroy these limited traces, the city becomes effectively invisible. Archaeology relies on patterns. A single artifact or isolated hearth is not enough to indicate a city. Without a cluster of activity indicators, researchers cannot identify a settlement. In regions shaped by ice, such clusters rarely remain intact. Patterns of soil compaction can reveal where people once walked or gathered. But compaction records are delicate. They rely on consistent pressure over time. Floods, storm erosion, and glacial pressure completely disrupt them. Once the soil layers mix, compacted zones lose their structure. Without these subtle signatures, the ground reveals nothing about earlier footpaths or gathering places. Storage pits present another interesting example. People often dig pits to store grain, tools, or seasonal resources. These pits fill with soil after abandonment. If left undisturbed, they can be identified through soil discoloration or changes in texture. But in glaciated regions, soil layers lose their integrity. The pits collapse under pressure. Meltwater deposits fill the cavities with new sediment. Later, freeze-thaw cycles break the layers apart. Without stable sediment boundaries, researchers cannot distinguish the pit from surrounding soil. The feature disappears. Fire pits provide some of the most durable evidence of early human occupation. Charcoal can survive for thousands of years. But in regions affected by storms, flooding, and glacial pressure, fire pits can become scattered or diluted into surrounding sediment. Heavy rainfall can wash charcoal into rivers. Wind can blow lighter particles away. If the region later becomes submerged, water disperses the remains even more thoroughly. Without a concentrated cluster of charcoal, identifying a fire pit becomes impossible. If nothing remains to show where people cooked or gathered, one of the key signatures of daily life vanishes. Another feature of early cities is waste accumulation. People living together produce refuse. Broken tools, discarded bones, and damaged containers often collect in specific areas. These refuse zones become useful archaeological indicators. But erosion and glacial movement remove these accumulations easily. Bones exposed to moisture decay rapidly. Broken tools scatter in unpredictable ways. Over time, these clusters break apart until nothing remains to identify a communal centre. Thinking about how deeply a city can vanish requires looking beyond visible remains. Even chemical traces degrade. Soil enriched by repeated human activity eventually returns to its natural composition once plants take root. Roots break apart soil structure. Microorganisms alter chemical signatures. If new vegetation grows repeatedly in the area, the soil memory of earlier use becomes overridden. After thousands of years, the soil no longer reflects human presence. Some researchers consider the possibility of detecting early cities through magnetic surveys. Human activity can alter the magnetic properties of soil, but such signatures depend on stable environments. Glacial mixing disrupts magnetic patterns entirely. Floods can spread magnetically active soil across wide regions. Without stable boundaries, magnetic readings become ambiguous. Technologies that work well in stable ancient sites produce limited results in glaciated landscapes. All of these factors lead to one clear understanding. The bones of cities that existed long before the last ice age may not lie in tidy ruins beneath the soil. They may exist only as traces too faint to identify. A broken stone tool here, a changed soil layer there, a fragment of bone, or a faint discoloration might be all that remains. Such clues, scattered over large regions, rarely appear in patterns strong enough to confirm a city. Instead, they join the vast catalogue of ambiguous findings that suggest human activity, but do not reveal its scale. Considering this, the silence surrounding such cities does not indicate that they never existed. It reflects the limits of preservation. The Earth itself does not protect every story. Some are lost to the shifting of continents, the grinding of ice, the rise of seas, and the steady work of storms. What remains are faint hints, and the recognition that absence of evidence is not evidence of absence. The landscape continues to hold possibilities that require patience and new methods to explore. If cities can vanish, what can be said about the people who lived in them and the choices they made? How might their lives, habits, and movements leave traces subtle enough to persist even after the physical structures disappeared? Thinking about a world that ended without witnesses requires taking slow, careful steps into the spaces left behind by time. Such a world might not have vanished in a single moment. It could have faded gradually as climate patterns shifted, as ice expanded, as coastlines changed, and as people moved away in search of livable conditions. The ending of that world would not have been observed by anyone who understood its full significance. It would have been felt only in small adjustments, in subtle changes to daily life, and in the steady disappearance of familiar landscapes. A community might have reached a point where life no longer matched the seasons or resources they depended on, and without a formal announcement or final ritual, they would have left their homes behind. The world they built would then fall slowly into silence, unnoticed, except by the land itself. Understanding how such an ending occurs means looking at how climate shifts affect human populations. Early humans relied on predictable weather, accessible water, and stable food sources. When any of these changed drastically, communities had to adapt. At first, the changes might have seemed manageable. Winters grew slightly longer. Certain plants appeared later in the year. Hunting routes shifted. Water sources froze earlier or dried unexpectedly. Families made adjustments. They travelled farther. They diversified their food sources. They learned to store more for difficult seasons. But as the changes continued, the strategies that once worked became insufficient. Generations growing up in this era would have known a world slowly losing balance. Their focus would have been on survival, not on preserving the memory of the place. One of the defining characteristics of a world that ends without being witnessed is the gradual nature of its disappearance. Sudden catastrophes leave clearer signatures. They disrupt layers, bury structures, and preserve momentary snapshots of life. Gradual endings, however, leave almost nothing. The people simply leave. Their belongings deteriorate. Structures collapse. Plants reclaim the area. Animal populations adjust to the abandoned space. Over time, the original shape of the settlement becomes difficult to identify. When the ice finally arrives, the final traces vanish. Nothing remains to show how many generations lived there or what their daily life looked like. To picture this, imagine a community built along a fertile river valley during a warm phase before glaciation. The river provides fish, water, and transportation. Surrounding land hosts edible plants and animals. Families build homes near the water. They mark areas for storing food. They create meeting spaces. For a long period, life in the valley is stable. Children grow up knowing where to gather berries or how to navigate the river's turns. Elders recognize cycles that repeat every year. Knowledge is passed down in predictable ways. As the climate begins to shift, the river responds. It freezes more frequently. It floods unpredictably. Sections of the valley become swampy while others dry out. Animals move to different elevations. Plants bloom at new times. People adapt until the adaptations no longer work. Eventually, the valley no longer supports the community. Younger generations, those with fewer ties to the land, become more willing to leave. Older generations understand the change must happen even if it brings a sense of loss. The group moves on. They take what they can carry and leave behind what cannot travel easily. Their departure marks the beginning of the valley's disappearance. Storms break apart the remaining structures. Floods redistribute loose materials. Soil erodes from certain areas and accumulates in others. Vegetation spreads across open ground. The abandoned pathways disappear under new growth. Animals dig through the abandoned storage areas. Over time, seasonal cycles erase the remaining order. When the glacier arrives, it compresses everything left in the valley. The land under the ice becomes unrecognizable. By the time the ice retreats, the valley's earlier history is gone. The people who once lived there remembered it only through stories passed down temporarily, and once those families migrated further or changed traditions, even those stories faded. This kind of ending, where nothing dramatic occurs, makes it more difficult to imagine that entire communities once thrived in regions now barren or reshaped by ice. The absence of catastrophic markers should not be taken as evidence that a world did not exist. It simply means that the process of disappearance left nothing preserved. Without sudden burial, structures collapse slowly. Without fire or volcanic activity to seal a moment, artifacts scatter. Without stable sediment layers to trap soil patterns, compaction disappears. What remains is a landscape that gives no sign of the lives it once supported. Another scenario involves coastal regions that were exposed during glacial periods but submerged afterward. A community might have lived on a broad coastal plain when sea levels were low. The plain would have offered abundant resources. Rivers emptied onto wide deltas. Plants grew in fertile soil. Shellfish and fish were available in large quantities. People could build settlements at a comfortable distance from rising tides. Over time, this coastal world would have developed distinct patterns of life. People would have understood where fish migrated, where storms were likely to strike hardest, and where the safest paths lay. When the ice melted, sea levels rose. At first, the change might have been barely noticeable. Tides reached slightly higher areas. Storm surges became more powerful. Flooding occurred more frequently. People adapted for a time, but as sea levels continued to rise, the entire coastal plain slowly disappeared. The community may have moved inland, abandoning the settlement. Structures left behind were exposed to water and storms. Once submerged, waves disrupted the remains. Lighter materials washed away. Heavier materials settled unevenly beneath sand. Over hundreds of years, sediment accumulated on top of the submerged plain. Marine organisms colonized any exposed surfaces. Whatever remained of the settlement became part of the seabed. This ending occurred without a dramatic collapse. No single event defined the moment when the world ended. Instead, it ended gradually as the conditions that supported life disappeared. The people who once lived there continued their lives elsewhere. They adapted to new environments, taught their children new patterns, and lost connection to the previous landscape. After a few generations, the details may have been forgotten entirely. Only general memories remained. Stories about ancestors who lived near a sea that did not exist anymore, or references to lands that no longer made sense in the new geography. Another possibility involves highland communities that lived on ridges or plateaus affected by intense freeze-thaw cycles. Such communities might have constructed homes from stone, clay, or wood. They may have relied on moderate climates during interglacial periods. As colder conditions returned, the freeze-thaw cycles intensified. Stone walls cracked, clay hardened and fractured. Water seeped into the smallest openings and expanded when frozen, prying materials apart. The structures weakened gradually. People rebuilt repeatedly until rebuilding was no longer possible. Eventually they left. These kinds of endings rarely preserve clear archaeological signatures. When a community abandons a weakened environment, the remaining materials quickly degrade. Storms scatter debris, animals disturb the ground, soil accumulates in depressions. If the area later becomes covered by snow and ice for extended periods, the evidence undergoes even more disruption. By the time the ice retreats, only scattered stones remain, and even these stones may have moved significantly from their original positions. Without stable context, they cannot be recognized as part of a city or settlement. Thinking about worlds that ended without witnesses also involves considering the spread of knowledge. When a community moves away from its homeland, it carries its knowledge with it. But this knowledge may not retain its full detail. Stories become simplified. Landmarks lose relevance. Skills suited to the old environment may not be needed in the new one. Over generations, the knowledge changes. If descendants eventually settle in a region with entirely different resources, their earlier traditions become disconnected from their new reality. Eventually, only fragments of cultural memory remain. Without material evidence, those fragments cannot be connected to a physical location. A world that once existed becomes a memory with no visible anchor. Some archaeological sites contain hints of these lost worlds. In rare cases, researchers find stone tools in layers that seem older than expected, or in regions where current models do not predict human presence at that time. These finds do not form complete stories. They suggest the possibility of earlier habitation without revealing its full nature. In other cases, soil layers show unexpected chemical signatures, indicating repeated burning or organic activity inconsistent with natural patterns. These clues may represent the far edges of vanished worlds, the faintest trace left behind from generations who lived in places no longer visible. Patterns of migration also support the idea that worlds ended without being recorded. Genetic studies show that ancient human populations moved through regions that do not align with the current archaeological record. These movements imply that people lived in or passed through landscapes now underwater, buried, or heavily transformed. The absence of material remains does not contradict the genetic evidence. It simply means the remains did not survive. When people left those regions, the world they built continued only in their descendants, adaptations, and knowledge systems. The physical world they knew no longer exists in a form recognizable today. Considering all of this brings attention to how fragile early worlds were. A community did not need to collapse dramatically for its world to disappear. It only needed to face enough environmental change to make continued occupation impossible. Once people left, the land rapidly reclaimed their structures. Storms, animals, vegetation, and geological shifts completed the process. Over time, the place that once supported life became a landscape with no visible indication of its past. Without witnesses who understood the significance of the final moments, the ending passed quietly. Recognizing how many times this may have happened brings a broad perspective to the study of early human activity. The archaeological record is incomplete not only because early materials were fragile, but because entire landscapes disappeared under ice or water. The people who moved away from those landscapes carried only parts of their world with them. The physical structures that might have explained their daily lives, social organization, or innovations vanished long before anyone could record them. Rather than beginning with the landscape itself, it might help to start by focusing on the people. The question of whether minds similar to ours once moved across regions now buried under ice rests on what we understand about early human cognition, problem-solving, and adaptability. The physical world changed repeatedly during glacial cycles, but human intelligence did not need advanced technology to navigate those shifts. The capacity to observe patterns, develop strategies, teach skills, and adapt behavior existed long before written records. When asking whether minds like ours could have lived in environments now erased, the most useful place to look is at what humans were already capable of during earlier periods. Evidence from known archaeological sites shows that early humans made complex decisions even when their tools and structures were simple. They selected materials carefully. They understood how to manage seasonal food sources. They coordinated group tasks. They adapted migration patterns based on animal behavior and landscape changes. These actions reflect reasoning shaped by the same cognitive foundations we possess today. Although the cultural expressions of that reasoning differed, the underlying mental processes were not primitive. If groups with these abilities lived in regions later overtaken by ice, their daily activities would reflect the same problem-solving approaches seen in other early populations. It is also useful to consider the range of environments early humans were willing to occupy. Groups living tens of thousands of years ago settled in deserts, highlands, river valleys, open plains, and coastal regions. They survived droughts, floods, volcanic eruptions, and dramatic climate swings. Some groups adapted to cold environments remarkably well, learning to manage food storage, clothing, shelter construction, and group cooperation in ways that supported survival. If these groups could thrive in harsh climates that remain challenging even today, then the idea of them exploring or inhabiting areas near advancing glaciers is plausible. The plains surrounding glacial regions offered resources that attracted people. Herds of large animals migrated through these regions in predictable patterns. Rivers flowing from melting ice provided fresh water and fish. Grasses and smaller plants grew during warmer intervals. People who understood how to follow resources would have recognized the advantages of these environments during certain seasons. They may have developed strategies for moving in and out of colder areas depending on weather patterns. If they used the land in cycles, their presence might not leave dense clusters of artifacts. Their seasonal movement would produce light archaeological signatures, which could be erased easily by the environmental changes that came later. Another important point involves how humans communicate and learn. Long before complex writing systems existed, people shared information through speech, gesture, and demonstration. They described land features, taught navigation routes, and explained methods for hunting or shelter building. These teaching practices required sophisticated cognitive abilities. A group that understood how to explain techniques and store knowledge mentally could survive in unfamiliar environments. If such a group lived near glacial edges, they would have mentally mapped the region even if they never created physical maps. Their awareness of the landscape would have shaped their movement patterns and decisions. Recognizing these abilities leads naturally to the idea that groups with minds like ours would have responded to environmental stress with creativity rather than defeat. When faced with colder climates, they might have improved clothing by selecting thicker hides. They may have adjusted fire management techniques to increase heat efficiency. They could have modified shelters to block wind more effectively, or insulated them with materials available locally. These adaptations require observation, experimentation, and shared instruction. Each of these steps reflects cognitive functions we still rely on today. It is also worth noting that early humans developed social structures that supported collective problem-solving. Groups relied on cooperation to hunt large animals, gather resources, and protect children. They made decisions about when to move and where to settle. They negotiated roles, resolved conflicts, and shared responsibilities. This social complexity allowed them to adjust to environmental shift with coordinated action. If a group lived near glacial plains, their social organisation would help them navigate changes in resource availability. They could determine when to move away from regions becoming too cold, or when to return during warmer intervals. Considering the wide range of tools early humans produced, it becomes clear that their minds were capable of planning and foresight. A stone blade shaped for cutting meat required understanding of angles, pressure, and material choice. A scraping tool used to prepare hides reflected knowledge of surface textures and efficient motion. Hunting strategies often involved anticipating animal behaviour, coordinating group movements, and preparing tools in advance. These cognitive abilities, when applied to the challenges of glacial environments, would support survival even in landscapes that look hostile from a modern perspective. The ability to create symbolic meaning is another sign of cognitive depth. Some early populations carved shapes, painted surfaces, or arranged objects in meaningful patterns. These activities indicate self-awareness, memory, and communication beyond immediate survival. If groups with this level of cognitive ability lived in regions later erased by glacial cycles, their cultural expressions would have vanished along with the physical environment that supported them. Their symbolic behaviour would not appear in the archaeological record unless preserved in rare conditions. The absence of evidence does not imply that such behaviour did not occur. It reflects the fragility of symbolic materials when exposed to storms, water flow, and glacial pressure. Exploring this idea further requires looking at migration patterns that existed during glacial periods. Many early groups travelled long distances in search of food and better conditions. Their movement often covered hundreds of kilometres across varied terrain. This level of navigation requires strong memory, spatial reasoning, and the ability to recognise environmental cues. When moving across frozen plains, people would have watched the position of the sun, the behaviour of animals, the direction of winds, and the formation of ice. These observations helped them determine safe routes and avoid hazards. Only a mind capable of processing complex patterns could make sense of these signals. Some migration routes passed through regions that were later reshaped completely. Meltwater floods carved new channels, and storms altered the ground surface. Ice sheets expanded over plains where people once walked. Because the land changed so drastically, the pathways used by these early groups left no trace. Even if thousands of people crossed those plains over many generations, their footsteps would disappear. Their campfires would leave faint charcoal traces destroyed by flooding. Their shelters would collapse and be ground into the soil. The people themselves may have left behind descendants who moved into other regions, but the physical evidence of their presence on the frozen plains would not survive. Looking at genetic studies adds another important dimension. Genetic markers show that populations move through areas now considered unlikely places for early habitation. These movements do not align perfectly with current archaeological discoveries. The mismatch between genetic evidence and material evidence suggests that many populations lived in regions where their physical traces did not survive. Their minds, problem-solving strategies, and cultural habits contributed to their survival, but the environments they occupied removed nearly every clue about their daily lives. This reinforces the idea that cognitive ability existed even where physical evidence does not. Turning attention to how early humans adapted their living structures sheds more light on the issue. In colder regions, people built shelters that maximized insulation. They used animal hides, bone frameworks, compacted earth, or snow. These materials do not survive well in changing climates. Hides decay quickly. Bone becomes brittle and breaks under pressure. Earth structures collapse during freeze-thaw cycles. Snow structures leave no trace once melted. Even if people lived comfortably in these shelters for generations, the physical evidence would vanish almost immediately after abandonment. Yet the ability to design such shelters reflects thoughtful planning, resource awareness, and understanding of environmental pressures. Another aspect of cognitive complexity involves food storage and resource management. Early humans stored dried meat, preserved plants, and prepared materials for future seasons. These practices indicate long-term thinking. People do not store food unless they understand future scarcity. This ability suggests that early groups living near glacial edges predicted seasonal changes. They recognized that winter would bring challenges and prepared accordingly. Their minds operated with a sense of time and planning that closely matches our own. Looking at the tools used in colder climates also reveals significant intelligence. Needles made from bone, for example, require fine motor skills and an understanding of sewing techniques. Clothing designed with these needles provided warmth against harsh conditions. Such clothing would eventually decay, but its creation demonstrates sophisticated cognitive abilities. People capable of making fitted garments could survive in extremely cold climates, including areas near glacial plains. It is also useful to consider how early humans managed fire. Fire allowed them to cook food, stay warm, and create safer living conditions. Managing fire requires knowledge of fuel sources, airflow, and timing. In cold environments, people had to be especially careful. Wet or frozen materials do not ignite easily. Maintaining fire through difficult weather conditions required planning and skill. These abilities reflect a level of intelligence fully consistent with modern cognition. Group cooperation plays another central role in this discussion. Tasks such as hunting large animals, building shelters, and protecting young members require communication and shared intentions. Groups capable of coordinating actions in this way possessed minds that understood collaboration, cause and effect, and future consequences. These cognitive traits would support life even in regions facing environmental stress. If such groups lived on frozen plains, their cooperation would help them navigate the difficult conditions, even if no physical evidence survived. When exploring the possibility that minds like ours once occupied these regions, it becomes clear that advanced cognitive ability does not depend on monuments, preserved art, or durable tools. It depends on daily actions, decisions, and adaptive strategies. These intangible elements are lost easily when a region undergoes multiple cycles of erosion, freezing, flooding, and glaciation. The absence of visible evidence does not reflect the absence of intelligent life. It reflects the difficulty of preserving anything in unstable environments. As this possibility becomes clearer, The focus shifts toward how groups with minds similar to ours might leave behind traces that are not immediately recognizable as human. Perhaps they shaped landscapes in small ways rather than building large structures. Perhaps they used organic materials that decayed completely. Perhaps their social systems relied more on knowledge passed through generations than on physical tools. These patterns would not survive glacial transformation. Instead of beginning with what this civilization might have achieved, it may be more helpful to start by outlining the conditions that would have shaped its development. Any community growing in a world that would later disappear beneath the ice would face environmental pressures unlike those in many well-studied regions. These pressures would not prevent cultural growth. They would simply direct it along different paths. The tools, structures, and ideas that flourished there would reflect the resources available, the climate patterns that shifted regularly, and the challenges of living in a landscape that alternated between opportunity and instability. A civilization in such a region would not need monumental buildings or elaborate writing to reach a meaningful level of organization. It would need coordination, memory, skill, and the ability to maintain social ties through changing conditions. A good starting point is the kinds of settlements this civilization might have built. If the land offered fertile soil during warmer intervals, people would likely establish communities near rivers or lakes. These water sources served as anchors for early populations across many parts of the world. Families could farm, fish, or gather from the wetlands. Settlements may have expanded outward from these core areas as food resources increased. People could build homes with materials suited to the climate, such as timber, thatch, clay, or combinations of organic fibres. Such materials decay quickly when exposed to moisture, wind, and freezing temperatures. But while they stood, they would have supported complex activities. Organised communities often develop specialisation. Some individuals would become skilled in tool-making. Others would manage food storage. Some might focus on gathering plants or caring for animals. As the population grew, these roles would become more refined. The ability to organise labour efficiently reflects social coordination and shared expectations. These are important indicators of a functioning civilization, even if no physical records remain. In a pre-glacial world, such specialization could have evolved without producing the kinds of durable artifacts commonly associated with ancient societies. The disappearance of these materials leaves the impression of absence, but the underlying behaviours would still have existed. Agriculture may have played a role as well. Even small-scale cultivation could support population growth. If people learned how to manage certain plants, they could rely less on unpredictable hunting and gathering cycles. Early farming practices often leave subtle signatures in soil chemistry, but glacial activity can erase these signatures completely. If a civilization farmed areas that were later scraped clean by ice or submerged by rising seas, nothing would remain for modern researchers to examine. This does not make the agriculture any less real. It simply highlights how fragile the evidence can be. When groups become more settled, social structures grow increasingly complex. Families form alliances, communities develop norms about cooperation, conflict resolution, and shared resources. These aspects of civilization leave behind very few physical markers, yet they define how people lived and interacted. If disagreements arose, individuals would rely on leaders, elders, or group consensus. Decisions about hunting, farming, or movement required communication and planning. All of this activity reflects a level of cultural development impossible to detect after thousands of years of erosion, flooding, and glaciation. Still, the absence of traces does not diminish the likelihood that such systems existed. Another part of imagining this civilization involves how it might have communicated knowledge. In many early communities, storytelling served as the primary method of teaching. People passed down information about seasonal cycles, useful plants, migration routes, and environmental hazards. Skilled individuals taught others how to make tools, prepare food, or build shelters. These forms of knowledge transfer rely on memory rather than writing. If the civilization existed before durable writing materials became common, its intellectual achievements would be preserved only in the minds of its members. Once the population dispersed or changed languages, the earlier stories could shift or disappear. Without preserved texts or long-lasting carvings, the intellectual world of the civilization would be invisible today. Considering trade adds another dimension. Even small civilizations exchange materials over short distances. Groups living near rivers or coastlines often develop simple trade routes to acquire goods that are scarce in their immediate region. They might trade stone for fibers, fish for grains, or crafted items for natural resources. Trade networks also promote social interaction between groups. People share ideas, tools, and stories. Such exchanges influence cultural development significantly. However, trade rarely leaves behind large, durable artifacts unless carried out on an industrial scale. If the civilization operated primarily through small exchanges, the evidence would be difficult to detect after environmental disruptions. It is also reasonable to consider that the civilization may have developed seasonal patterns rather than continuous settlement. Some communities used a set of locations throughout the year, following animal herds or plant cycles. These seasonal settlements could form a recognizable network. People would return to the same areas regularly, bringing knowledge and materials with them. Over time, these locations would hold social significance, functioning as meeting points, marketplaces, or ceremonial areas. Yet because these sites may have been used only part of the year, and built with impermanent materials, they would not leave robust archaeological signatures. Once storms, floods, and glacial cycles altered the land, the entire seasonal network could vanish. Another part of the civilization's potential identity involves creative expression. Even without durable materials, people often create forms of art using pigments, wood, textiles, or clay. These expressions communicate ideas, mark events, or strengthen group identity. But pigments fade, wood breaks down quickly, textiles decay unless preserved in sealed conditions. Clay fragments might survive but scatter easily through erosion. If the civilization produced art that relied on organic materials, it would be lost entirely in regions where weather and ice reshape the land repeatedly. The only remaining evidence would be indirect, such as residues or faint soil discolorations, which are easily erased. Looking at technology, it is likely that this civilization developed tools suited to its environment. In warmer intervals, people could craft fishing equipment, baskets, or nets. In colder intervals, they might create insulated clothing, handheld heaters, or improved fire management techniques. Bone needles, hide scrapers, and cutting blades could form the basis of a sophisticated toolkit. While some stone tools survive longer than organic ones, the movement of ice and flowing water can scatter and fracture them. A few isolated fragments may remain, but they would not reveal the full range of the civilization's capabilities. Comprehensive toolkits reflect thoughtful design, planning, and problem-solving, all of which point to a society capable of adapting skillfully to uncertainty. The civilization's food systems would also be shaped by the fluctuating climate. People might store meat in pits lined with insulating materials. They may dry or smoke fish. They might collect and preserve plants during peak seasons. These practices show long-term thinking and coordination. In colder regions, such strategies are essential for survival. Storage methods made from organic materials leave no long-lasting record. Even the pits themselves can become distorted or filled with debris after centuries of storms and soil movement. The complexity of the food system becomes invisible, despite playing a central role in the civilization's success. Another meaningful area to consider is childcare and education. Any civilization capable of sustained growth must support younger generations. People would have developed methods to protect infants from cold, feed children during periods of scarcity, and teach them necessary skills. These efforts require planning and cooperation. They also reflect a society that values continuity. Because childcare practices rarely leave behind material evidence, They are absent from archaeology unless preserved in unusually stable environments. Still, the existence of a thriving civilization implies that such practices must have existed. Expanding further, it is reasonable to consider the role of health and medicine. Early societies often recognized healing plants, developed treatments for injuries, and understood the importance of rest and nutrition. They observed which plants reduced pain, which helped with digestion, or which prevented infection. Such knowledge becomes part of cultural memory. It influences daily life and shapes how communities respond to illness. But medicinal knowledge leaves behind no clear archaeological signatures unless written or carved. Without preserved records, the medical practices of a vanished civilization cannot be reconstructed. When exploring the potential scale of this society, it is helpful to imagine population patterns that respond to environmental pressures. Communities might expand during warm intervals when resources are abundant. Populations could decline during colder phases. Over time, groups might merge, split, relocate, or adapt. The civilization could exist for thousands of years without ever producing large population centers. Instead, its influence might spread through consistent practices, shared knowledge, and stable networks. These forms of civilization are difficult to detect archaeologically, but are entirely plausible. Trade, art, communication, farming, and social structure all suggest a civilization that could grow and adapt, yet the physical world beneath the glaciers would eventually remove the evidence. Buildings would collapse under storms long before ice arrived. Wooden supports would rot. Clay materials would crack. Stone foundations would scatter. Sediments would bury what remained. When ice advanced, it would grind the surface, mix layers, and compress the land. After retreat, meltwater would reshape the terrain again. The bones of the civilization, its buildings, tools, pathways, and landmarks, would be lost. What remains today are landscapes that hold no visible signs of the worlds they once supported. Reflecting on this leads to another important point. Even if the physical remains vanished, the civilization's influence might persist indirectly through the people who left. Their descendants could have carried knowledge, skills, and stories into new regions. They may have contributed ideas that shaped other communities. These influences would merge into broader cultural patterns, making it impossible to trace them back to their original source. The civilization becomes part of human history, without being identifiable as a separate entity. This possibility reminds us that civilizations do not need durable artifacts to have existed. They need people capable of cooperation, memory, planning, and creativity. They need communities that share knowledge across generations. They need strategies suited to their environment. All of these traits could have developed in regions later erased by glacial cycles. The absence of evidence reflects the nature of those environments, not the limits of human potential. Returning toward the present can begin by slowing the pace of the exploration rather than ending it. After spending so much time imagining landscapes altered beyond recognition, and people whose traces have slipped beneath layers of earth and water, it becomes useful to step back into the world we know and consider how these ideas fit within it. The ground under modern feet feels stable, but the history of that stability is short. The continents shift, the climate changes, coastlines move, rivers carve new channels every year. Seen from this perspective, the present becomes one moment in a much longer sequence, and imagining earlier worlds becomes less about fantasy and more about recognizing how deeply the planet transforms itself. Looking at today's landscapes with that awareness reveals how much motion is hidden beneath the surface. A forest may appear permanent, but soil studies show that root networks, moisture layers, and mineral distributions change constantly. A coastline might look solid, yet satellite imagery shows it retreating by meters each decade. Even a mountain range that seems immovable undergoes slow erosion and uplift. When thinking about civilizations that might have existed long before written memory, these constant shifts become important. They show how easy it is for entire worlds to disappear without leaving behind an obvious signature. They also demonstrate that the present landscape offers only a partial view of what once existed. Modern tools allow scientists to reconstruct environmental changes spanning thousands of years. Ice cores reveal temperature fluctuations. Ocean sediments show changing currents. River terraces indicate flood histories. These tools give a sense of how dynamic the planet can be. Yet even with these methods, the resolution fades as one looks further back. Data becomes less clear. Layers become mixed. Signals weaken. This limited clarity mirrors the difficulty of imagining the daily lives of people who lived in eras now buried under reconstructed landscapes. The further back one looks, the more gaps appear. Filling those gaps requires careful reasoning rather than firm conclusions. With that in mind, the present moment feels connected to the imagined past not through evidence but through patterns. Human behaviour adapts to environmental pressures. Communities grow when conditions allow and relocate when they do not. People create stories, tools, knowledge systems and social structures suited to their needs. These patterns appear repeatedly throughout known history. It would be unusual if they did not also appear in earlier periods. This consistency supports the possibility that people lived in places now erased by glacial movement. Their worlds would differ in detail, but not in the fundamental traits that shape human life. Stepping back into modern times also means looking at how researchers approach the unknown. Archaeology relies on fragments, a broken tool, a discoloured layer of soil, a cluster of bones. These fragments form the basis for reconstructing entire societies. But when glacial forces, storms and time remove most of the fragments, the reconstruction becomes impossible. This limitation does not reflect a lack of human presence. It reflects a lack of preservation. If one were to take a modern town built largely from wood, plastic and metal, then subject it to thousands of years of erosion, storms, flooding and ice pressure, almost nothing would remain. Even concrete would crack, steel would rust, plastics would break apart. Only isolated traces would survive, and even those might be transported far from their original location. A future researcher might find a handful of objects disconnected from context and conclude that the region was sparsely inhabited, even if a dense community once lived there. This comparison makes the present easier to evaluate. The fragility of modern structures mirrors the fragility of ancient ones. If physical traces from today can vanish within geological time, then earlier traces would do the same. The gap between what existed and what remains becomes larger with each passing era. Recognizing this helps frame the earlier discussion not as speculation, but as a realistic response to the limits of preservation. Returning to the present also encourages reflection on how humans interpret absence. A lack of evidence often becomes a placeholder for assumptions. When a region shows no archaeological material from a certain time period, it can be tempting to conclude that people were not there. But absence does not automatically indicate emptiness. It can indicate destruction, transformation, or burial. The challenge lies in distinguishing which explanation fits. The regions once shaped by ice complicate this task significantly. Their records have been mixed, crushed, or carried away. Understanding this encourages a more cautious approach to interpreting gaps. Another way to approach the return to the present is by considering what remains constant. Humans look for patterns to make sense of the world. They observe seasons, track animal movements, and build tools to improve daily life. These behaviours exist across cultures and eras. They also persist even when physical evidence fails to survive. A vanished civilization may not leave behind structures or artifacts, but the fundamental behaviours that allowed it to thrive would mirror those seen in known societies. These parallels help anchor the imagined past to a more grounded understanding of human capability. Shifting attention to the present-day landforms themselves can be helpful. Many regions, once covered by glaciers, now contain rolling hills, scattered boulders, and mixed sediments. These features show how completely the ice reshaped the terrain. Any earlier structures, paths or settlements would lie beneath these reworked layers or be removed entirely. Standing in such a landscape today offers no hint of the worlds that may have existed there. The surface appears natural and untouched, yet its shapes result from processes that erase earlier histories. Recognizing this helps bridge the gap between imagination and physical reality. Modern scientific instruments can sometimes detect deeper layers beneath these surfaces. Ground-penetrating radar can reveal buried channels or compacted zones. LIDAR can strip away vegetation in digital models to expose ancient terraces or abandoned watercourses. These tools expand the ability to look into the past, but they cannot overcome all obstacles. Thick deposits left by glaciers interfere with radar signals. Waterlogged sediments distort readings. Many promising regions remain difficult to examine thoroughly. Even with advanced tools, the past remains partly shielded. As the focus moves between past and present, the idea emerges that the world today contains only a partial record of earlier human presence. Entire coastlines from the last glacial period now lie underwater. Warm period valleys once filled with vegetation may lie beneath the layers of gravel left by meltwater floods. Plains that supported herds and human populations may now serve as farmland or forests, bearing no resemblance to their earlier forms. Acknowledging this makes it easier to understand how a civilization could exist, thrive, and then vanish without leaving behind obvious traces. When stepping back into present awareness, it also becomes possible to consider how humans today interpret time. Modern technology allows precise measurements, rapid communication, and extensive record keeping. These capabilities can create the impression that history is smooth and well documented, yet the timescales involved in geological processes stretch beyond the reach of written records. Human civilizations occupy only a narrow part of Earth's timeline. Most of the planet's history unfolded without observers. Even within the span of human existence, vast regions remain unrecorded. Returning to the present with this in mind offers context for imagining earlier civilizations whose stories did not survive. Another area to examine is how modern people connect emotionally to the idea of lost worlds. There is an understandable curiosity about what came before. Imagining earlier communities allows people to see themselves as part of a longer story. It also encourages humility in understanding how quickly environments can change. The landscapes people rely on today may not resemble those of the distant future. What feels permanent now may someday be unrecognizable. This perspective softens the transition back to the present, making it easier to hold both the known and the unknown in view at the same time. Returning from the imagined past also brings attention to how fragile knowledge can be. Information passed through generations must be preserved intentionally. If a community undergoes major environmental disruption or disperses into new regions, its stories can shift or fade. Without a stable system of writing, these stories change over time. Even with writing, records can be lost. Fires, floods, and conflicts can destroy them. Recognizing this highlights how easily entire chapters of human experience disappear. This recognition becomes part of the process of moving back into the present. Thinking about modern research emphasizes how incomplete the current picture remains. Each year brings new discoveries. Some finds challenge previous assumptions, others reveal unexpected connections. These discoveries demonstrate that human history is still being assembled. The idea of a forgotten civilization beneath ice fits within this broader pattern of expanding knowledge. As understanding grows, earlier questions become easier to revisit with new tools and new perspectives. Returning more directly to the present moment means considering what can be learned from this exploration. The imagined civilization was not defined by grand monuments or preserved cities. It was defined by its adaptability, its responses to climate shifts, and its ability to build meaningful lives under challenging conditions. These qualities reflect traits still seen today. Modern societies adapt to environmental pressures, innovate in response to challenges, and build communities that support shared goals. The imagined past mirrors the present in ways that help bridge the distance between them. Shifting attention toward contemporary concerns, it becomes clear that studying earlier climate changes can inform modern understanding of resilience. Human populations have survived dramatic shifts before. These experiences, even if undocumented, remind us that adaptability is a deep part of human identity. By examining how people may have adjusted to past changes, it becomes possible to think more clearly about how to approach current environmental challenges. Returning to the present can also involve acknowledging the limitations of certainty. Much remains unknown, but this does not diminish the value of exploring possibilities. Imaging earlier civilizations is not an attempt to replace scientific evidence. It is a way to understand how much of the human story may lie beyond what can be recovered physically. Holding this understanding gently allows modern inquiry to remain open, curious, and flexible. As this movement back toward the present continues, one more element becomes important. The search for earlier civilizations does not depend on finding definitive evidence. It depends on recognizing how easily evidence disappears. This understanding reshapes how the past is viewed and encourages patience in exploring it. Each discovery, no matter how small, adds to the story. Each question encourages new research. Each possibility widens the space for understanding. Reaching this point in the narration does not close the exploration. Instead, it shifts the orientation back to the world we know, leaving room for further questions, new studies, and future discussions. The imagined landscapes remain part of the broader picture, offering perspective as attention moves forward again, carrying the long arc of earlier ages into whatever comes next.